Good morning, Harold.
Okay, now that should work. Yeah, it's morning, all right. It's a Monday morning.
It is a Monday morning indeed. Yep.
Yeah.
Yeah. Well, at least two of us got in okay, so that takes care of my first worry.
Yeah, yep. And as usual, my video is going wonky for some reason. So you see my background, right?
Yes.
But you notice it ends because part of the background is my background, and then the other part is actually the room.
Ah,
It's been doing this constantly, so it's like
right.
it gives a headache.
So who's the kitty on your lap there in the background?
That's Amy Lou.
Aw.
She's like, right now, because I moved, so she's sitting outside of the office door on a rug looking in at me because she hears Zoom meetings. She is fascinated by Zoom meetings because I talk to the screen.
Right.
She's also like, so this one is like, if I turn the TV on,
Uh-huh.
she's up there right in front of the TV screen,
Oh,
looking around. And the other day, she was particularly interactive with a Kevin Belton cooking video
oh, how funny.
because he was, stir
Right.
frying, and like
Right.
that. So she's up trying to like,
Oh,
it's like, okay, okay.
I know. I've had mine really watch tennis, right? And their little
Oh,
heads
yeah.
go back and forth.
Yep, they'll do that. But lately, she's like, I've been binging old Enterprise on Netflix.
Mm-hmm.
She's like, she hears that theme song, she comes running, and then she's sitting. It's sort of like the cat I had before these two. Particularly liked the intro to NCIS New Orleans
Oh, how funny.
as it goes boom, 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 bang, 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 bang. And for some reason, wham, she was right there. It's like, whatever, whatever. So how many do you have?
I think we're gonna have close to 30.
No. Cats.
Oh, sorry. How many cats for
Yeah.
me? I currently have 5 indoors,
Oh, all right.
but unfortunately the vet is coming this afternoon. I have to euthanize one this afternoon.
Oh, that's the problem. Old, just
He's
old age.
not that old, but his kidneys have failed. They think it may be a tumor.
I have two
Um,
cats.
yeah, so that's always really hard. Um, and then there's one outside who showed up this spring that I'm taking care of. Yep.
Toying with the idea of getting a third.
Sorry, what was that?
I've been toying with the idea of getting a third,
Yeah.
and it's just because of this mug,
Oh,
right? Because there's 3.
that's right.
Got to be
Right.
3. And I don't know how these two, and you will probably like, Rory will have a problem because if she sees another cat outside,
Yeah.
probably
Yeah.
she goes ballistic.
Yeah.
So I'm told that kittens are not treated the same way.
They're not as threatening, I think. Yeah. Yeah.
So I mean, I've had these now girls for 1 year. 1 year
Aw.
anniversary. First,
They're fun.
take them into the VDT to get SHOTs, but I mean, they're going to be traumatized by that.
Yeah, I found a vet who does house calls.
Mm.
He's semi-retired, and this is kind of what he's doing now. And I like him a lot, and it definitely helps.
The last time these two were in a carrier, when I was taking them home from the shelter,
Right.
it was a very traumatic experience for both of them. Because they were kind of like, I showed up and I thought they would have had all of the exit stuff done already. I show up, so they get yanked out of the cage, they get like
Yeah.
chipped and
Yeah.
probed and shot
Right.
and stuffed into this carrier, and then this weird guy pulls him in a car and drives off with him.
Right.
Okay. Uh,
Hi, Chris. Whoops. I think you're still muted, Chris.
yeah, she must
There
be.
we go.
Hi, Harold. Hi. Harold, that is a hilarious background. You look like you're like a puppet on someone's lap with a cat.
Yes.
I love that. Sorry. Very amusing.
Well, it was either that or this one.
Good to see you haven't lost your sense of humor. Well, that one's good.
See now, Kimberly, this one, the background doesn't bleed through.
Ah.
So, who knows?
Should put my
And of course, there's just my messy office. Anyways, that's because it's still used as a storeroom, and I had to get something, so a whole bunch of stuff had to get moved. Chaos.
If you position your head just right with the United Nations, you have a laurel crown like.
Yeah, that Judy pointed that out, so that's why it's like I don't use that. I have to do something about the side.
Here we go. I guess we should acknowledge that we are being recorded. So
Oh, from the get-go?
yeah, yeah.
Well, you can delete all of that.
I think yeah, we can
So hopefully you can edit this video later on to cut out.
yeah. We did this for Monday because there are some people who can't come and would still like to hear sort of the introductory talks. So
Oh, this is important.
hi Malcolm, hi Stan.
Good morning.
We're trying to wake up. That's what we're trying.
I think I'm just going to quickly go and grab a cup of coffee.
What are those, Harold? Are those the porcupines, is it?
Yes, they are. Yep. This is a view from Cadillac. And if I expanded it, you can see my house from Cadillac.
I don't know about anyone else, but I'm finding there's kind of a lot of noise on your line, Harold.
Yeah, probably. Microphones and my USB system and on this computer and microphones do not get along.
Has the snow gone away, or you still got some?
Oh, yeah, well, it melted a couple. We had, it's shovelable snow 2 weeks ago, and then it melted, and we had a spell that got up to 60s and 70s, but now it's plunged back down to the 30s. So, normal. I don't like these all of a sudden really warm states. When they're abnormal, like I go out with buds on the trees, bushes and stuff. Then it freezes, of course. So.
Hello, everyone.
Yay.
Hey David.
Harold, what a lovely view you have from your house.
Yeah. I think so.
I have a different monitor, so I'm not looking at
I
that.
hardly recognize
It's because I got my COVID beard.
you. Yeah.
It isn't going away anytime soon either.
And who's this guy that looks a little bit like Chris Christopherson on the side?
It's funny, I took a virtual guitar class yesterday with one of my guitar teachers, and he had no idea who I was over Zoom.
One day we should all show up wearing our masks. Yeah, I broke a set of 12 strings, so it's like
Whoa.
I'm faced with restringing and I'm not looking forward.
I've got 3 guitars that need restringing, and every weekend I say to Amy, I'm going to restring my guitars this weekend. I have yet to do
You really should stop saying that.
it.
Oh, wow, John.
It's going to get wicked cold, Harold.
Yeah, well, I finished redoing the gutters that I could reach from Mo, Larry, and Curly Joe, putting the gutter guard in backwards.
Oh, you're kidding
They
me.
lined the gutter rather than have it, go the opposite direction. And I noticed it because I looked up and I saw leaves and gutters. And I think, well, how in the hell can that happen?
Oh, man.
Sure that I could get at with a ladder comfortably. It's like, yep, they put them in backwards. Of course, it was pitch black by the time they got here. They were with headlamps up on the ladders. I could never use those guys again, for sure. Finished mulching all the leaves,
Oh, man, you're way ahead of me.
put everything away, all of the stuff. Roof rake is out, lined by the grill. Snow shovels are up.
It's not supposed to snow. It's just supposed to get really cold.
Yeah.
Thanks everybody for coming. We'll just hang on a few more minutes. So we probably only have about half the people who signed up who are actually on the Zoom right now.
I invited the other 2 Xenopus curators to see if they can come today or tomorrow if they have time.
Okay. It's all good.
We don't get charged by the day.
Good morning, Paul. We're just going to wait a few more minutes for other people to join.
Thanks, sounds good.
Okay, I think why don't we go ahead and get started? I expect that a few more people may come on board as we go along. But I know it's later in the day for some people and very early in the morning for everyone, but I think everyone would probably appreciate it if we get started. So I will share my screen. Okay. So to start the Jamboree this week, we're just going to have our introductory talks today. And so I'll start out with the welcome and the introduction. All right. And just let me know, can everybody see and hear okay?
Yep.
Okay, great. So welcome everybody to the 2020 Noctua GO-CAM Jamboree. We really appreciate everybody taking the time to be here with us for all or part of the week. Getting ready for this Jamboree, I actually went back and looked at the number of Jamborees that we have had, and we started with our first one almost 5 years ago at the SIB in Geneva. And then the following year in 2016, we actually had 3, another one at the SIB, one at the EBI, one at USC. And then the very last one that we've had was at Oregon State in Corvallis in June 2017. So it's been quite some time since we've done one of these Jamborees. And we felt that a lot has, excuse me, has changed with respect to particularly Noctua and the development we've done there. Our thinking on GO-CAM modeling has evolved a bit as well. And so we thought all of that combined with the fact that the Go grant renewal will be going in end of January, early February, that it was a good time to get everyone together to do this GO-CAM Jamboree. Unfortunately, I think, or maybe fortunately, that we're able to do this. This is virtual. But wherever you would most like to be, you can think of yourself for this one this year. So this is roughly an outline of the Jamboree agenda for the week. So like I said, today it will be some introductory talks. We'll go through some example models illustrating some of the principles of GO-CAM modeling with those models. And we'd like to have people sort of begin to make your own models. So last time I double checked, everyone who is on the call and participating is all set up with their Noctua accounts. This is really meant to be, even though we're virtual, this is really meant to be a hands-on kind of thing. So the more modeling that you can actually do this week, I think the better. And then, so Tuesday, Wednesday, Thursday, in the middle of the week, really what we'd like for this to be is, we'll check in at the beginning of each day and address any questions that may have come up, do some more hands-on modeling, and then sort of get together for the last hour or so each day to have some group discussion. So we really want to emphasize that this is meant to be an opportunity for everyone to learn and for all of us to discuss things. So please feel free to ask as many questions as you need to. That's what we're here for. We really want people to come away from this, with a lot more confidence in making GO-CAMs and using Noctua. And then Friday, our last day, I think we'd like to have some final discussion sections, get some feedback from participants about the process, and then talk about some of the more forward-thinking ideas and things that we'd like to do with Noctua and GO-CAM on the very last day. So again, you'll hear some more about this from Paul, but just to be clear on really what our goals are for this week. So we want all the participants to be comfortable using the Noctua landing page and the form and the graph editor. We want people to be confident that they understand the general principles of GO-CAM modeling, that people are also aware of the different causal relations that can be used in GO-CAM and how they're used. We'd love it if by the end of the week, everyone was able to create at least one process-centric model. And then we would really like also, like I said, to get feedback from curators, on how you feel about the workflow, the process, Noctua, the tool, and particularly we'd like to get some sense from people of, how much time it really took you to create a process-centric model. And this is important, again, for the upcoming Go grant renewal, because we'd like to have an estimate, at least a better handle on the amount of time that it takes curators to make these models. So before I turn it over to Paul, there are some thank yous in order. So there's a GO-CAM modeling working group that, besides myself, is David, Pascal, Paul, and Sabrina. Special thank you to all of them, because we've had some very informative and lively discussions that have helped us set the stage for this Jamboree. I also want to acknowledge some other people who've really contributed a lot to our thinking about GO-CAMs, and this is just a subset of the people on the Pathways to Go project, because it overlaps as well with the modeling group and the software team, but Peter and YU on that project. Especially big thanks to the Go software team. So there are a number of developers, Laurent Philippe, Jim, Seth, Eric, Justin, Ben, Chris, and especially Tremaine, who's done a lot of the recent Noctua development. They have all been extremely supportive and helpful in getting Noctua and other aspects of this project coming along. So huge thank you to them. And lastly, to everybody who signed up and who will be participating in the workshop this week. We really value your input and your feedback. We appreciate the time that you're putting in, and we really hope that you get something out of it this week as well. So with that, I will turn it over to Paul, unless anybody has questions to start. Like I said, we want this to be really interactive, so feel free to jump in, ask questions at any time. Okay, if not, then yeah, I will turn it over to Paul, and he will sort of go over the GO-CAM philosophy.
Thanks. Yeah, so I think many of you have heard this before, so I'm not going to go into a ton of detail, but just kind of try to go over the basics and get everybody oriented. But again, just feel free to, as Kimberly said, feel free to ask questions, because I think this is really important to get everybody kind of on the same page and get us off to a start here. So I apologize if I sound a little tired. It's a little early here. All right, let me see if I'm capable of sharing my screen. Okay. All right, can everybody see my slides here? Yeah, can you see them okay? Okay.
Yes.
Yeah.
Yes.
Great. All right. All right, so they're not pretty slides. I apologize in advance, but hopefully they'll be clear. Okay, so I'll try to just go through these one at a time here. So the first thing I wanted to really just emphasize is that mostly this is not going to be new to anybody who has done Go annotation. Okay, so the whole idea behind GO-CAM is that it allows multiple Go annotations to be linked together into a model. So the new part is the linking part. What's not new is the Go annotation part. So it's really just Go annotations, and I don't want it to sound like it's something so different from, I think, what we're already familiar with doing. So it's important just to say that it's not intended to replace Go annotation. It's adding additional functionality on top of what you're already used to doing. There's no need or requirement to link together annotations, but it does, but GO-CAM does provide the framework to do it if that's something you want to do. And so for the purposes of this Jamboree, we're really thinking about, what would it look like to build biological process-based models. So things like pathways, and actually specify how gene products work together to accomplish larger biological processes. And so in this context, it's probably easiest to think of putting down a framework for that process in a slightly different process than some annotators use. So I know some curators annotate Go annotations in a paper by paper way. And obviously when you're trying to put together and look at how a number of gene products act together, you might want to consider doing that in a different way. And then once there is a model and a sort of a framework for a biological process, then it's pretty straightforward. Then when new papers come along, to add them to the model or to revise the model. So that's at least what I would ask people to consider for a process for this, and I'll go into that in a little more detail. But again, the main point is that all the existing annotation guidelines still hold, and that of course includes all of the perennial debates that we have in coming up with Go annotation guidelines. It's not simple. It's not going to be simple in the context of GO-CAM, and you'll probably see that as we go through some of the examples today, some of the issues around Go annotation, things like when do I use annotation to biological process X term instead of regulation of biological process X. These sorts of issues that we've had for a long time with Go annotation. You'll see those again. Okay. Oops, I guess I'll just
Paul, just to say in between, when we kind of model, I often, you still, because we still do just developing and often of annotations that we partially or so have already, and then they end up being different a bit in the GO-CAM because we have all these relations. So I often then in the GO-CAM don't use the regulation term. So I think that is kind of a good discussion to, when to use certain things are regulatory, and then you, I guess, use the regulation term, but when it's just a regulation term of a normal kind of process, then it's the question, I think, just to throw that in.
That's right. That's right. And so we'll get to that. And I think the whole idea behind this, yeah, it's a great point, Petra. And I'm not going to try to go over all of these in the introduction. I think the idea here is that we really want people to get hands-on experience, and you'll see as you start to build these models, and we'll try to answer questions and go through issues that people have, and then make sure we review any issues that people come up with the larger group, so that everybody can benefit from those discussions. So yeah, thanks, Petra. That's a really good point. Okay, so just in keeping with that whole philosophy, just think of GO-CAM as building on top of the existing guidelines. But what it allows you to do is to link annotations together. And really the way we think of it, and the way we've conceptualized, I'll show a picture on the next slide, is that these annotations can be linked together into an activity unit. So just think of it as, a gene product performs a molecular function while it's located in a cellular component, and that molecular function is carried out as part of a biological process. Okay, so I think it's what we all have sort of assumed is the meaning of Go annotations for a long time, but it really specifies it and is clear about it, right? A molecular function is sort of a molecular level activity of a gene product. And it must be performed somewhere relative to the cell, and that's going to be the cellular component. And the cellular component has always been ideally where the gene product is active, and so that really fits with that definition. And then, of course, a biological process has always been defined as an ordered series of molecular functions carried out to accomplish a biological aim. So we really just tried to formalize that and allow curators to actually specify that structure. Okay, so you can also think of it as then that each of these annotations can include what we've traditionally been doing as Go annotation extensions, using other ontologies. So you can link to, the cell type if a particular function is really specific for a cell type, or a particular tissue. Or it operates on a particular small molecule. These sorts of things are still within bounds for GO-CAM. So again, it's just extending on the things you already know. But then the thing that really is, I think, new, as Petra pointed out, is that these activity units can then be linked together into causal chains. And that really just means that, the activity of gene product 1 or an upstream gene product can causally affect the activity of a downstream gene product. And I think we've kind of had that in the gene ontology with regulation of molecular function terms. But of course, the important thing in biology is not only specifying what the downstream activity is, downstream function is, but it's what gene product is it. And so that's what we're really trying to capture here is the specificity of that causal chain. So this is from the paper. I hope people had a chance to look at the paper before the Jamboree, but if not, this is the sort of focal picture from it. And this just sort of lays out what that activity unit looks like. And so a molecular activity is carried out by a gene product. So really this is just a statement that would be the same as a molecular function annotation, right? A molecular function is enabled by a gene product. So there's your molecular function annotation. That's how that fits into this unit. And then the linkage here really is the CC annotation, right? It's saying that the gene product is active in a particular location. And then you can say the gene product carries out its activity as part of a biological process. So there's your biological process annotation. And so the evidence for a biological process annotation would go on this triplet statement here. Evidence for a cellular component annotation would go here. For a molecular function annotation would go on this triplet. And then the extensions that you're used to seeing are things like the gene product or chemical that the activity acts upon. So that evidence would go here. That's the extension for what it's acting on. And then when it's occurring is this happens during. So when is that occurring? What biological phase? So that can be like a developmental phase or a cell cycle phase. So this is all, I think, more or less what everybody's familiar with, but a structure for sort of linking it all together. Okay, and then causally, then one molecular activity can affect a downstream one, and I haven't put in all of the different elements of this second activity unit, but this one also is a second activity unit. Okay, so it really just allows you to specify in the model how the flow of the causal flow goes through the pathway. So anybody who's looked at pathway diagrams, and I think that's probably all of us in papers, will sort of recognize this general structure. Okay, so does that make sense? And are there any questions about that? This might be a good spot for a question.
Well, it is also always a question with GO-CAM to, where does a model end and where does the next model start? Because there is so many pathways that intersect and stuff. So that is also then, ultimately when you move fully to GO-CAM, so where to end and where to start a new model. For those of you who are further along the path, maybe that's something later on we can discuss a bit more.
Yeah, it's a really good question. So the way that the model, at least the framework, has been structured, there's no prescription for how to do that. So we can come up with guidelines, and we actually have thought a little bit about guidelines, but think of it as, a model is really just an arbitrary, whatever you think is a curatable chunk of biology. If we already actually have the ability on the back end, to store causal relations from one model to the next. So the whole notion of a model is really kind of arbitrary. Just think of it as what you would like to curate as a unit together.
Okay.
Yeah. And so I would sort of say, because the curator tools don't allow you to link yet from model to model, I'd say sort of err on the side of more inclusive and larger, as long as you think that it's not going to become overwhelming for you. But in the very near future, we'll be able to link from,
but the
from
system also
model. And then you probably want to think about modularity.
Yeah, and when it's the same annotations that end up in 2 or 3 models, because it's quite upstream in a long branching pathway, then you would kind of, on the back, of course, notice that there are redundant annotations, so they are the same, just used in different models, right?
Right, that's right. So yeah, so we can always help on the computational side to link things up post hoc. So I would say, yeah, don't worry about it too much would be my answer. Just build the, put whatever on it in a model that you feel comfortable with.
If I may, just a small comment about that.
Yep.
At the last Go meeting, we saw a very nice example of Ben working on a reactome where he was merging all the GO-CAMs together and providing like this gigantic graph. To some extent, that's actually something we could do with GO-CAM. So for the moment, even so, that's a very good question, and we don't have an answer. I think the beginning and the end of GO-CAM is not really an issue, because we will be able to merge them to some extent later on.
Yeah, really good point. So yeah, so don't worry too much about that. It's really just, whatever you feel comfortable with. Okay, any other questions before I go on to my next? I've got a few more slides. I'm about halfway through. Well, not quite halfway through. I'm halfway through the tough ones. Okay, so I have here just a rough sketch, and we'll go over this more, and you'll see this in the other presentation, so I'm not going to spend a lot of time here. Just to give you an idea of how we have sort of found it to be a useful way to go through the workflow of creating a GO-CAM model. And so I think everybody will have a little twist on this. but just kind of how to conceptualize it. So this might be helpful for people. So step one, I think of as, just prepare for it. Just think about what you will do when you model. And so, that includes decide what the biological process is you want to model. What's the process? What's the pathway? Do you want to look at, DNA mismatch repair? I don't know. What's the sort of deep, biological process that you'd like to model? And then once you have that, put together a list of the gene products that are in that process. Okay, and to do that, obviously, we've got our existing Go biological process annotation. So you can look up that biological process in your organism or other organisms to see which which gene products in your organism may be involved. You can look online at pathway diagrams and resources. Other resources like Reactome, like Biopsych, or whatever pathway resource, KEGG. And then the other source, of course, is review papers. So the review papers that tend to put these together and spec out what a pathway looks like. And we've found that it's often useful to look at multiple review papers because as each lab sort of comes at a pathway from a particular viewpoint and the specialty that they have within that pathway. And so that's sort of one way to think about how one might start collecting those gene products. And then once you have those gene products, then the various resources that you've assembled can help you sketch how those gene products are sequentially ordered in that process. And of course, I don't mean literally, they're not all perfectly in a sequence, right? You can have a branching, it might be a branching metabolic pathway, it might be a branching signaling pathway, or it might be an integration of several signals that come in to regulate transcription of a particular gene. So again, just think about what the causal ordering between the various different activities of the gene products involved is. In what order do they happen relative to each other? And this may be well known or it may be less well known, and so there you might just be able to specify something's upstream, and or you may not even know. You may not be able to connect them all up, and that's okay. So again, just in keeping with gene ontology annotation, just like in Go annotation, we don't always know everything perfectly specifically. So we can always say much less in our models if we don't know it, right? If you don't know it, that's the whole idea about the knowledge base, is you don't put anything in that isn't known. Okay, so then the second step is to start building that model. And the first step is really then to create the activity units. Okay, so for each gene product, okay, what is, how can you make that activity unit around that gene product? And we recommend that you do that in Noctua form. And I'm not going to go through the workflow, but Kimberly will later on and really walk through the various different stages with the curator tool. But the idea is then we want you to be able to use the knowledge base. There's tons of Go annotations already. And so she'll show you how you can actually import existing annotations so that you don't have to re-annotate something if it's already annotated. You can basically just bring it into your linked model. And so you want to use the existing annotations when possible. Of course, create new annotations where they're missing, and the tool allows you to do that as well. And just starting to get into some of the nuances of GO-CAM, but I think, again, this is probably obvious to all curators, which is, sometimes a gene product can have more than one activity. It might have more than one domain, for example, and each domain may have a separate biochemical activity. And so if a gene product has more than one molecular function, you might need more than one activity unit. And that's okay. That's in keeping with Go annotation. And so, I think, again, Kimberly will give examples of how to handle that. And then the last step is then once you have all the activities, you can go to the graph editor view and link together those activities. And I'm not going to spend too much time going over the various different relations. We'll talk about the relations in much more detail later on. But just to give you a flavor for the causal relations, there are relations that specify, things like, the second gene product the downstream gene product operates on the product of the upstream gene product. Okay, so in a metabolic pathway, for example, right, and one gene product catalyzes a reaction that has a particular output, and that output is an input to the next enzyme in the biochemical pathway, and so there's a relation for that. And then for other sequential activities, there's always going to be the language of the direction of effect, which is obviously important. But if you don't know it, again, it doesn't need to be specified. So there will always be a positively influences or negatively influences, but you always choose the direction of effect if it's known, obviously. So it's known to be a positive effect or negative effect. And then if one gene product controls the next one, activity controls the next one, use regulates. So this is really building on what we think are our current guidelines for use of regulation terms and when you annotate. And then if it's unknown, use causally upstreama, or if it's really not conceptualized as a control, use causally upstreama. But again, I'm not going to get into a lot of detail. Please save questions about this when we actually go through examples. It'll be so much easier when you see examples, but I just kind of wanted to introduce the concepts. And then, there are certain issues that everyone will run into. And so we've tried to go into those beforehand, and I won't try to really answer those here. Again, the presentations after this will give you real examples that you can look at. But some of the things that you'll see just to sort of prepare you are things like, when you go in and try to choose an annotation, choose an existing annotation to link into your model. Often for molecular function, you'll have only binding annotations. And they may be only part of the function that you really are looking for. So the question you can ask yourself is there a more informative term that could be used or requested? And so, for example, let's say, something's in there like, protein kinase binding. But it actually might be a protein, your gene product might actually be more accurately described as a protein kinase regulatory subunit, in which case we have Go terms like protein kinase regulator activity. And so just think about these kinds of, whether you think that that's a good Go term, or whether there might be evidence for a more accurate and complete molecular function annotation. So it's just something to consider. You can still use the binding annotation, but just something you might want to think about, because we find that these curators often have these questions when they try to make models. And then another one is how to handle protein complexes. And so, when you have a diagram of a pathway and there's a complex performing, that you might want to model in a pathway, how should you do that? So that's obviously, I think, a really common issue that comes up. And the answer, I think, again, is default to the guidelines for Go annotation. So really just think about the annotations that we've always had for contributes to, when you use the contributes to qualifier for molecular function. Okay, so we've always said that when you use the contributes to qualifier when there's a complex performing a function, and you can't really ascribe that molecular function to any one subunit of the complex. So you're going to annotate the whole thing with, or all the different subunits with contributes to. In GO-CAM, what we would do is build a complex, and we'll show you how to do that. You basically can just use a Go complex term and link the gene products to it, and then make that the enabler of the activity. But you should really only do it when you can't decompose the functions of each of the complex subunits. So really just exactly as we would do molecular function annotations. Since Go is always, the main use case for gene ontology annotations have always been at the level of gene products. We want to be able to provide the users with a statement about what that gene product is doing, if we can. Sometimes, for some things like, the subunits of the ribosome or the subunits of the proteasome, I think these are things that I think we'd all agree are, irreducible complexes, where it doesn't really make a lot of sense and to talk about the individual functions of each subunit. And so in those cases, those are examples of complexes that you want to actually have specifically specified as a complex. And so again, we'll give more examples, and I'm sure people will come up with more examples as we go through the actual annotation. But again, just to sort of get you thinking about, usually the answer to your question is think about the GO guidelines, the GO annotation guidelines, and usually that'll help answer the question. And then how to handle regulation by transcription factors. Again, I would suggest we follow the transcription factor annotation guidelines. Pascal will actually have a presentation about this, so I don't want to take up any more time. So just to have one more summary slide on the goals. Obviously, there are two things I think we'd love to be able to get out of this, and I would just ask if everybody could do us a really big favor for the second one of these, which is obviously the first of these is, we'd love everybody to gain a facility with annotating with the Noctua curation tool and kind of understand the basic workflow and feel comfortable with it. But then the other thing we would request, as Kimberly said, is that it would really help for the upcoming gene ontology grant, which is going to go in January, for us to be able to estimate the effort that's required to create models of biological processes, so that we can get kind of a ballpark estimate of what it's going to take to cover the biological processes, and basically link together the annotations that we already have, plus, as I said, potentially add additional annotations to create these models. And so I would just ask if people could, during this Jamboree, just please track the approximate time you spent on the models for each of the steps. In other words, for the steps that I sort of spec'd out there earlier, which is how much time did it take you to prepare for this model? Looking at the literature or the existing pathway diagrams that you could pull up. So just separately track for each step how much time that took you. So how much was it what time was in preparation? How much time were you using the Noctua form? As I said, step 2A, the Noctua form to create the activity units. How much time roughly did that take you? And then how much time did it take you to link them all up again, into a single causal flow, at least where you had the information. So just to get an idea, because we'd love to get an idea of, where are curators finding difficulties, where are they spending a lot of time? And then of course, any feedback you have on improvements we can make to the tool, and where you sort of feel like that, it took you a lot more time than you feel it should have. This would be really, really helpful for us to hear, to guide future development. So, again, I just want to thank everybody for being here. Thanks for taking your time, and I really appreciate all the effort it takes. I know we all have really, really busy schedules right now, and probably the last thing most of us need is another Zoom. So I really appreciate everybody being here, and really looking forward to this. I think it's going to be kind of fun. So any other questions or comments before I turn it over?
Paul, sorry, it's Val. I joined late. Could you post a link to these slides? I can't see it on the meetings page.
Yeah, I didn't deposit them. I kind of had expected to be awake a little earlier this morning.
Okay, I just wanted, if you could send a link, I just wanted to catch up what I'd missed already.
Yeah. So I'll pop these into the folders so that people can review them.
Okay, thanks.
Yeah, my apologies, everybody. All right. Great, thanks.
Okay. So what I'm going to do now is I'm going to give an overview of Noctua, and then I'm just going to walk through the basic workflow for the form and the graph editors. I know, like I said, we have a very wide range of people here today. Some people use Noctua probably almost on a daily basis, and other people I know are seeing it for the very first time. So I'll try to strike the right balance of illustrating the key concepts, but absolutely for the modeling, the hands-on modeling this week, if you have questions or need to see something again, by all means, please ask. That's what this week is for. All right, so let me share my screen. And then also just to say, after this presentation, we'll take a short break, and then we'll come back and start looking at some specific models, okay? So this is actually a repeat of a talk I gave at the virtual consortium meeting last month, but I just want to sort of bring everybody up to speed before we actually go into the demo. Noctua is the annotation tool that has been developed by the Gene Ontology Consortium that is used to create GO-CAMs and also can be used just to make conventional or standard Go annotations. For some of you who might be returning to Noctua after some time away, we have in the past year or so completely overhauled the Noctua landing page. So when you go to noctua.geneontology.org, this is what you'll see. And so basically it consists of, on the left-hand side, a number of different ways to search models, and then a list of models here in a table. And I'll go through the details about this some more. When you sign in or when you go to the URL, this is where you land. So like I said, and Paul has said, there are two different curation interfaces for Noctua. One we call the form editor, which is here on top. And the other is the graph editor, which is actually the first curation interface that was developed for Noctua some time ago. So these two interfaces have both overlapping and unique annotation functionalities. Over the next year or so, I'm hoping that we can sort of bring both of these two things closer together, have more of the same functionalities in both. You can use whichever one you feel most comfortable with, you feel you're most efficient using. And you can go back and forth between the two of them. If you start using the form, you can go over to the graph editor. These two interfaces talk to each other. So you're not restricted to one or the other based on what you might initially choose. There are also a couple of features that I'll point out from Noctua that might be helpful to people. One is an annotation preview, which will give you an idea of the kinds of annotations that will be exported from your model, the kinds of conventional annotations that will be exported from your model into the annotation file format, the GPAD file format. There's also a cytoscape view, which sort of collapses some of the detail or removes some of the detail, so it's a good overview. And then there are things like a reasoner and inference explanations that we won't get into too much at this Jamboree, but can sometimes be helpful for just giving you some feedback on the validity of the model that you're making. So this is just an overview right now of where things stand, or at least where they stood as of last month, with who is using Noctua and where they're at in the process. On top are the groups that we're aware have been using and trying Noctua. And then over here on the side are groups who have assessed the tool, who might be making some development models. There are a number of groups who also make production models, which means that those annotations are put into the public GO-CAM repository, as well as those models have annotations exported in that GPAD file format. And then Wormbase, I don't know if there are other groups who've started to do this as well. We have made some production models where we use new annotations as well as some existing annotations in the database. The idea is that for the groups who are making production models, that the data flow will go from Noctua back out to, right now it is still each of the mods. So a number of groups are doing that as well. We also have a project ongoing where what we would like is for ultimately Noctua to become the main curation tool for at least groups who are part of the Alliance, as well as other groups, say, for example, ZenBase, who has come on board recently. But for groups who in the past had their own curation tools or might have been using Protein to Go, what we're doing is we are importing all of the manual annotations made by those groups into Noctua, so that not only will Noctua have the new annotations that we might be making with models, but it will have the bolus of annotations that groups have made over, in some cases, the past 20 years of Go. And then there are some groups, like I said, with ZenBase, ZFin as well, who are using Noctua as their sole curation tool. So just a little bit about how Noctua is developed. So there is actually a working group for this, and we sort of call it the Workbenches Working Group. Largely consists of David, myself, 3 developers, as I mentioned, Tremaine, Lauren, Philippe, and Seth. Right now we meet twice weekly on Wednesdays and Fridays. And what we do is we discuss and prioritize items for development over basically 6-month development cycles. We gather requirements and specifications if there are new bigger projects that we're taking on. We implement and test the prototypes. As you can imagine, this is an iterative process. We go back and forth with this. And then when we're ready, we release those new features. So it's very important for us to get feedback from curators about things that you would like to see, things that you think maybe could be made more efficient for your curation process. We may not be able to address all feature requests immediately. Like I said, we try to work in these sort of 6-month development cycles, but if we can, squeeze some easier fixes in there as well, we try to do that. But if you have feature requests, the best thing would be to make a ticket in one of the trackers on GitHub. If you don't want to do that, you can also, by all means, email me and I can do that. So the trackers are really split out depending upon sort of essentially the workbench, right? And this is largely done for development purposes. I've put them here in the slides. There's a general Noctua one. If you're not sure where to put your request or your ticket, you can always put it there and we'll sort it out. But there is, say, for example, one for the form, one for the landing page. And I'll just note that one of the new features that we've been working on most recently is something we're calling the annotation review tool, or ART. And there's one for that. Hopefully, we will be able to demonstrate that, if not next month, then very early next year. And like I said, when in doubt, put your issue on the Noctua tracker. That's totally fine. So just a few considerations for Noctua. Noctua is under development. Like I said, that we have the working group. We're trying to add new features and respond to curator requests. But just something to know that we expect, I think, for some time to come, that we will be rolling out enhancements and bug fixes. As I said, only production status models have conventional annotations. I'll talk a little bit more about model status when I actually demonstrate the tool. But those are the only models that the annotations get exported into GPAD and then are available for the public to view. And so if you want to pick up those GPAD files, you can use this URL, current or snapshot as well, and pick up your Noctua or GO-CAM derived annotations in this folder. And this is just an example of what the file actually looks like using the worm-based file. So the rules for GPAD output are still under development somewhat. Noctua can create very expressive GO-CAM models. Sometimes that's reflected maybe even more than we might want for our GPAD output. This is something, again, that we plan to be doing some more work on in the future. But I would always recommend that if you have production models, check your GPAD output and make sure that you're happy with what you get for those annotations. And again, if you have any questions about that, you can always create a ticket in the Noctua tracker. Like I mentioned, there are some whole genome import annotations going on, particularly for MGI and worm-based. ZFin will follow. If you are interested in this for your group, please let us know. And lastly, sometimes there are Noctua outages. Noctua is currently hosted at the Lawrence Berkeley Labs. Occasionally they will have to shut down the servers for maintenance or for possibly some other reasons like fires. And we try really hard when that is going to happen to give people as much notice as we can. We send emails out to the Go Consortium mailing list with enough lead time that we hope curators can save your work. And then we try to get Noctua back up as quickly as possible. So if you're using Noctua, just make sure that you're on the Go Consortium mailing list so that you will be contacted if that happens. Okay. So there are any questions at this point before I actually go to a demo? Okay, if not, then we will go right to Noctua. Share my screen. Okay, so this is, as I showed in the slides, the Noctua landing page. So if you go to noctua.geneontology.org, this is where you will land. So it is, the landing page is basically divided up, like I said, into two sections. There's a section here, the table, that will show you all of the models that we currently have in the repository. They will be listed according to title, model state, the date last modified, and any curators who have contributed to them. By default, this table lists at the very top the most recently touched models. There is also in the table links out to view each model in either the form editor or the Noctua graph editor. If you are not logged in, you can certainly view a model in each of these, but you can't actually do any editing and you can't create new models if you're not logged in. And then also, as I've mentioned, you can export the annotations for a model either in the GPAD file format or in the turtle file format, which is the OWL representation for each model. So over on the left are the different ways that you can actually search for specific models. So the search really gets divided up into two broad categories. The first category is things that are in an ontology and say can be auto-completed. So ontology terms, it may be Go terms, for example. And these will autocomplete, and you can select from a particular menu item here. Things like also say anatomy terms are available there, cell types. You can also search according to a particular gene product. This is also an autocomplete. This is everything that we have in what's known as NEO, which stands for the Noctua entity ontology. I'll talk a little bit more about that when we actually go to the form. Other things, we have, say, contributors, because you may have all noticed that if you didn't have a Noctua account, I asked you for information, say things like your ORCID or the group that you actually annotate for, so you can filter on both of those things. You can also filter by reference. This is not an ontology, so you would actually have to either type in full query in there, or this feature, which will also demonstrate on the form. We have a drop-down menu of common prefixes for references used for Go annotation. You can type in an accession here, and then what we'll do, for example, it will go out to PubMed and just do a quick sanity check for you to make sure that that ID is really the PMID that you're wanting to search on. You can filter by date, either an exact date or a date range. And then you can also do so essentially a keyword search to match what's in the title, and then by model state. And so model state, there are currently 5 values. I think the only ones that right now curators need to be aware of are development, production, and delete. By default, every model that is initiated in Noctua will be a development model. And what that means is basically the annotations will not be exported in GPAD. It won't be available for public viewing. So if you're working on a model, it's in progress, you can keep it as development for as long as you like. When you're happy with it and you're done, you can change the state. I'll show you how to do that, change that to production. And then lastly, delete. We do a lot of testing, or if you're not, you don't want to keep a model around, you can flag it with delete, and ultimately we will clear out the model repository of those. You can also browse on these side menus. You can browse by contributor. This has the list of all the users in the Go consortium, not just Noctua. You can browse by the different annotation groups, and you can browse by species for which there are models. And then there's also a history. So we'll keep track of your search history. So if you want to go back to a recent search in this session, you can do that here. On the table, note that each of these boxes here, the state, the date modified, and the contributors can also be used to filter. So if I click on, say, myself here, what it will automatically do is that it will filter by the one contributor, me, and you'll see the value filled in here. So that's just another quick way of adding things you might be seeing here to your filters, and you can just clear that and go back to the landing page table. So are there any questions at this point? Okay, if not, then I'm going to go right in and show people how to, the basics of how to use the form and the graph editor. So
there was a question in chat.
Oh, okay, great.
Alan had a question in the chat about whether or not you can clone a model.
So at this point, no, but it is one of our highest priority development tickets for the software team, because we know that will probably really help people save some time in the future. Any other questions? Looks like Petra has a comment. It'd be nice to copy parts of a model to a new model. Absolutely, I agree. And so I think as part of our model copy and cloning, hopefully we will be able to do something like that as well.
So I would love it as people work, when you find examples of when you would want to do this, just make a note of them, because I also think it would be really nice, and I'll show you in my talk, to be able to copy parts of a model. But it would be nice to have a list of, here's why I want to be able to copy parts of a model, so that we can prioritize the development.
Okay.
Kimberly?
Yeah.
Yeah. I just thought I'd mention this. A while ago, I requested that one could also filter by model ID.
Yes. Yep.
Yeah.
And yep, so Tremaine has implemented that. It's on our development site. And so hopefully, right, once Jamboree week is over, we'll be able to go back and implement that and put that into production. But yeah, Tremaine has done that on the development site. Yeah. So yeah, just in case, what Harold, I'll show when I pull up a model, is that each model actually has a unique ID. And what Harold's asking, is it possible from the landing page to search with that ID? And that feature is coming. Yep.
Kimberly, is the filter by reference not working now or something? I was just trying to do one, and it looks like
okay. One thing you have to do for filter by reference, because it's not an autocomplete, is you have to hit return when you do that. So try that.
Oh, okay, got it. All right.
And that's sort of a general point about the filters here on the right. If it's an ontology term or it's an autocomplete, you can select it. It will automatically filter. But if we don't necessarily have it in ontology, hit the return button and then it should work.
All right.
All right. Okay, so and let's go ahead and do some hands-on here. So I'm currently not logged in. So I'm going to go ahead and log in, clicking on the green box here. So we use GitHub for user authentication. That's also why when you get an Noctua account, we always ask for your GitHub handle. You'll be taken to this page when you first log in, and just click here on the sign in with GitHub. That's all you have to do. All right, and then this will show you your session status. You really don't have to worry too much about any of this. Just make sure it's your name. Don't worry about the color. You'll notice that you'll get this long token, right? And that's just sort of something that you will get every time you log in, that's associated with you in that particular session. If you're going to ever share your URLs for a model, don't include the token in it. We're hoping to also implement some software updates that the token isn't included in the URL. But if you do, basically what will happen is whoever clicks on that will be editing that model as you. So basically, as long as your name is there, you're good to go. And you can click on return, and it will take you back to the landing page. And now you'll see you have two new options here once you're logged in. You can either create a new model in the form, or you can create a new model in the graph editor. Like I said, either one is okay. It really kind of just depends on your preferences. So for the purposes of demonstration, I'm not going to actually create a new model, but I'll show you how to use the tool by going to this development model that I have. So I'll start with the graph editor, or the form editor rather. So to get there, just click on the form icon. And it will take you to the Noctua form editor. All right, so this model, I already have some existing annotations in it, but let's say I want to add a new activity. And this would be, if you were creating a new model, this is exactly what you would do. So I want to create an activity. So this brings up a form that corresponds to the activity unit that Paul presented in his talk. So the boxes are pre-populated with some relations, and it's constrained to that activity unit. So you can use this to make just a molecular function annotation if you want. But if you also know that you can add part of and or where that function occurs, you can use this activity unit form. So we try to use as many autocompletes in the form as possible to make things efficient. So for a gene product, I'm just going to type in a C. elegans gene here. The genes and gene products that are available in the autocomplete here are either things that if a group submits what we call a GPI or gene product information file that could contain all of the entities that you might want to use for annotation, that's sort of the first choice that the tool uses. If your group isn't submitting a GPI file, and then the information that we have about entities for annotation are actually those that just exist in a GAF. So I would recommend that if you're going to be using Noctua a lot, that your group actually create a GPI file that has all of the entities in it that you want. And if you have questions about that later, you can certainly get in touch with us. We can help you with that. So then let's say I'm going to want to give this a function. So I can type in with the autocomplete and select the term. For evidence, we use the evidence code ontology, and you can either type in a 3-letter code, or you can always type in the term name or the eco ID. And for anything that there's an ontology that we use in the form, we have link outs to the appropriate term pages. So if you want to see more about it, you can go to that page. The reference here works the same way that it does as I showed you on the landing page. So I'm going to type in my reference here. And then if you're done and this looks like the right PMID, you can just click the checkbox and it will add it for you. Right now, the with field is used the same way we use the with from field in conventional annotation. This is not an autocomplete, not yet. We would love at some point to have it be an autocomplete. But I think as people are aware, the sort of information space that we could potentially use in the with from is even much greater than what we would annotate to. So it will take some work, I think, to get that enabled.
Kimberly,
So, yeah.
Sorry, that means there's no check that if you use an ISS, the width is also annotated to the same annotation, you know, like, or else it would already be in the information field that we have.
So that's a slightly different question, but I can answer that. So the question that Pascal is asking that, say if I wanted to do inferred from sequence similarity, right? And so the annotation rule there is that I need to say what the similarity was to. And for the entity that I've put in the with from field for that, there needs to be an experimental annotation. There is currently not right now a check in a sanity check in Noctua that will check that for you, right?
Okay.
So that's something that, yeah, curators, you know, have to make sure that when they do that. And that brings up a broader question about, you know, where we're putting some annotation checks versus whether they're in Noctua or whether they're later on in the pipeline. And that's something that's ongoing work right now.
Okay, thanks.
Yep. So like I said, the form for the activity unit is constrained to the model that Paul showed you. So if I'm going to use this form, basically the statement I'm making is that this kinase activity is part of a biological process. So with biological process, I'll illustrate another feature of the form that is quite nice, which is that what you can do by clicking on the 3 dots here is you can go out to all the annotations that we have stored at Go and you can import an existing annotation, right? So if I go to search annotations, it will bring up this window. It basically shows, here's the list of all the BP annotations to the SEC1 gene, right? So say for this model, I just want to say, all right, I'm going to make a defense response to gram-negative bacterium. And what you'll see are, these are all of the annotations that exist in the database. And for each one, you can select one or more pieces of evidence. You can put multiple pieces of evidence on any assertion in a GO-CAM. So to illustrate that, I'm going to pick all 4 of these and I will add them. And what you'll see is that it gives you a separate line for each of the annotations that I'm bringing in. And so that's a nice shortcut, and that allows us, right, to make use of what we already have. So some other things that you can do, and I'll just illustrate that with the component. So I'm just going to say this occurs in the cytoplasm. So let's say I have already used the same evidence code and reference in this model, and I want to just add that again. I can clone the evidence, right? And so if you go to evidence, you can see all the combinations that you've used. I can select one that I can reuse, populate that, and then you can add that. And so there might be some contextual information, say, that I want to add to this cytoplasm. Let's say I want to indicate what cell type it is. So again, in the additional actions menu, you can go to add an extension, as we call them. I can add that the component is part of a particular cell type. I'll say that this is part of, I'll use this one. We have in the Noctua ontologies that are available for curation, different cell and anatomy ontologies. And so this kind of illustrates this as well. So at the top, for example, we have the ZFIN anatomy ontology. We have the cell anatomy ontology, worm, Xenopus. We also have EMAP-A and Uberon. If you want to use a particular cell or anatomy ontology and it's not here, let us know and we can work with our software team to import that so it's available for you. So just for now, I'll pick this one. Again, I'm going to clone evidence as a shortcut. Go to evidence, clone evidence, and I can add that. Okay. So some of you may have noticed that while I was doing this, down here there was a save button and it was grayed out. That save button in the form will stay grayed out until you've really completed all of the information. Now that doesn't necessarily mean that you always have to add a process or that you always have to even add a component or a cell type, for example. What that just means is that there's some key piece of information that's missing so far that you'll need to be able to save. And so when it's grayed out, so I'll illustrate that. I'll just take out the evidence code here. Say, for example, I didn't add evidence. The form won't let me save, right? And if you click on this, why is the save button disabled? It will tell me that there's no evidence for the part of cell type, right? And so I have to go back and add that. And once I do, the save button is blue and I can save again. All right.
Kimberly, if you have another cell type, can you add it here too, or like a 2 cell type?
So would that be that the gene product is located in 2 different cell types?
Or you need another model? That's my question.
Yeah, so if I was going to make, if I wanted to show that a gene product was actually located in 2 different cell types, I would actually make that as 2 separate activity units.
Okay.
Yeah, so it really you kind of have to think about, as Paul was saying, you know, if you're going to if the goal is ultimately to make process-centric models, it might be that when a gene product is in different cell types, maybe it's doing slightly different things, or it's interacting with other entities, right? And so if that was the case, I would typically make a separate, at least a separate activity unit for that, possibly even a separate model.
So can I just ask a question? If, because presumably a lot of these things are going to be already annotated, and since we've already been connecting up function part of process for a couple of, well, for a number of years, quite a few, all of this should be already, we should, because I just tried one and I put the function in, and then I have to do the process and connect it up when I've already done that. Do you see what I mean? Is there a quick?
You've already done that for your conventional annotations, Val.
Yeah, so I'm actually repeating myself by doing this.
Right. So I think that, so I kind of have two answers for that. One is, I think, you know, as we've talked about the whole genome imports, we've kind of talked about if, you know, if those extensions already exist, right, they'll be imported like that, right?
So when you came to the protein kinase activity, would it show you when you came to select the function, would it show you that was already connected to the process? I'm just thinking about tweaking the models. Yep. Maybe it'll become apparent later. I'll have a play around.
Yeah, no, I think that, you know, what we have right now, Val, and maybe this is something we could explore with the software developers, is that, you know, if you have a function annotation in, you know, in the Go annotation store that already has a part of process extension, you know, of maybe somehow possibly, you know, highlighting those, or maybe limiting or giving the curator the option to import that, you know, as an existing activity unit. But we haven't done that as of yet.
Kimberly, Ruth also has her hand up.
Okay. Ruth?
Hi there. This is, you know, it's lovely demonstration. Thank you. I just wondered, following on from Lee's comments, really, so is it possible just to duplicate this activity form once you've saved it and then just change the cell type?
Yeah, so that, like I said, the model copy and duplicating things is very high on our development priority list. So we'll be doing that. You can copy nodes in the graph and do that and make some changes. And
okay, good.
I can share that. Yep.
Nice.
So Colin has
so
a Tanya has a chat.
Can I go? My question is, I didn't get the width field. So what do we do with the width field?
Okay, so the width field in Noctua really works exactly the same way as the width field for conventional annotation, right? So there are certain evidence codes for Go annotation that require an entry into the width from field. So for example, say if you're inferring something from a genetic interaction, you make the annotation to one gene involved in the interaction, and then in the width from field, you would say enter the second gene that's involved if it was a binary interaction. So that's the use of width from, like I said, it's the same as it is for standard or conventional annotation.
Okay, thanks. Can we put this a SO, a sequence ontology thing there?
I would need an example, Colin, I think.
Well, do you mean like a binding to a motif? Because we had said we would use has input for this. And so this goes in kind of the extension column, not in the width column or field.
Yeah, usually the width from field is referring to a specific entity.
That would be the case, but so for the moment it's a protein, right?
It could be a protein, it could be a gene.
Ah.
Yeah.
Thank you.
Yeah, it could be anything, right? It could be, let's say, technically an RNA, right? You could have a binding with some RNA, but I think also we were trying to move away from using the width field from interaction, at least protein interaction. If we say protein binding, we wanted to use has input instead of
Thanks,
width.
Pascal.
Yeah,
Yeah.
that would be right. We'll separate discussion, right?
No,
We-
I know, but I think this is where, just from talking to Colin every second day, I think this is where he's coming from, but maybe not.
Okay. Well, that's something we could definitely talk about during the week. I think that would be a good topic to talk further in the week. Yep.
So Kimberly, Tanya has a question in the chat as well.
Okay.
I can say it out loud. I was wondering if you'd run into cases where the evidence for the cell type, and the example we're looking at here, it's the intestinal valve cell, is different from the evidence for the cytoplasm annotation. And so I'm just wondering why the evidence isn't automatically cloned, and it implies that they can be different. And if they are, it's using two different references in one line. And that's just a little confusing for me.
Okay.
The answer is yes, they can be different. Right?
Yes.
So
Yeah,
you
go
have,
ahead,
you
David.
have different evidence that an enzyme acts in the cytosol from the evidence that it's the cytosol of a lung cell or in the lung.
Yeah, so you're right, Tanya. This is a case where it's a little different from how we have our extensions now, right? Where the extensions would just have the evidence, for the CC annotation, and then you just put an annotation, an extension in there. We just wanted to, when we were looking at how to do this in GO-CAM, because at least everything's decomposable into these separate statements. We at least wanted to give the flexibility, that perhaps those might come from different from different references, and the evidence might be different for those. But we can, if it's a matter of it's a pain to type in this twice, we could always make the default is it fills it in. Automatically, but then you could still change it. So I don't know. Anyway, just wanted to sort of just say what the idea was behind that was that, at least we thought it was possible that curators might want to actually use different evidence for those two different statements. And so at least it's possible to do it.
Right. I actually have an example model that I made recently where I did use different evidence on it. So we could look at that this week.
Yeah,
as well.
I've done it many times. In mouse, it's hard, you hardly ever get a cellular component annotation and then get the full extent of the expression of where that thing is in the same paper or with the same evidence.
Yeah, and then in answer to Val's question earlier, if you have worked on, and Val, I think we've talked about this before, but I just wanted to point this out to everyone. If you actually have already linked up, you've figured out which activities or parts of which processes, we can work with you, individually to make sure that we import those as GO-CAM models that are already linked together into, or at least put into the same model, even if they aren't, there's no ordering to the activities yet. We can still put them into the same models for you. So there's a lot of pre-processing we can do for people as we look at if you've spent a lot of effort on this already, just to avoid redoing work. So just keep that in mind if you've spent a lot of time on that. I don't know if other groups have done that, but Val, we'll continue to work with you on importing those.
Okay. Yeah, it might be better to do them rather than, I remember we did them now in one big fell swoop, which is really, it might be better just to do them process by process.
I think that's a great idea now that you put it that way. Yeah, if you just specify which processes you'd like to handle that way, we can just do those. Yeah.
Because I'm going to need to do them one by one, and just having them all is probably going to be a bit overwhelming. Yeah. Okay.
Yep. I think that would be really interesting to see, Val, what those process-centric models look like. Okay, great questions, everybody. Are there any others before I hit save? All right, so I'm going to go ahead and do that. And so then what happens is that we kind of have this table over here on the right. I'm just going to close the activity unit for a sec. And each annotation that you add in the form actually also gets added to this table. And so you can open this up and you'll see in a table-like format of what I've just added. So I've said that there's a protein serine threonine kinase activity enabled by SEC1. It's part of this defense response process, and that occurs in the cytoplasm, and that cytoplasm is part of this pharyngeal intestinal valve cell. Shows all the evidence if you've added a with from or a reference. Anytime you see this little pen icon, that means that you can actually edit this in the table. So if you found that you want to change something, in this activity unit, you can go ahead and edit it here and it will automatically save for you. Just a couple of things to note. The connect that's here, right now that's still under development, so there isn't functionality there. And then I would also caution there's this thing danger zone, delete activity. That's also something that right now is still under development. So remember I said it doesn't really matter whether you choose the graph or the form. That's something I think that everybody kind of has to figure out what works well for them. But you can go back and forth between them. And so here in the form, we also have the graph icon. So if I click on that, it will open up a separate tab and I'll see everything that I have added to this model displayed here in the graph editor. So these annotations over here on the right, those are things that I previously added to this model. And then here on the left is what the graphical representation of what I just added. So it's the kinase activity enabled by SEC1. It's part of this process that occurs in the cytoplasm and it's part of the valve cell. So you notice here that in the graph editor, you see these numbers on the relations edges. And so basically that just gives you an idea of the kind of evidence and other metadata that's on every statement that we make in the model. So for example, it has my orchid as a contributor, it has the date, the evidence that I imported, and that this is provided by, or the group that I'm annotating for right now is Wormbase, okay? And so the same thing for these little these green boxes with the E in it. That's where the evidence is on these statements within the node. And so again, you see my orchid as contributor, the date, the evidence that I imported, and that I'm doing this work while I'm at Wormbase, okay? So I will quickly then walk everyone through how I might actually make this same kind of annotation using the graph editor. So like I said, the graph editor was the first user interface that was developed for Noctua. So there are a few things that are lingering from early days of Noctua, or back when we used to call GO-CAMs Lego, which we don't do anymore. So for example, the activity unit right now in the form that's referred to as an annoton, and that's just a previous view of what we called activity units. But essentially, you can add one here as well. It works a little bit differently. So I'm going to put in an activity unit here. I'm going to select the nosy1 gene from worms. It's also a kinase, so I'll just go ahead and add my kinase again. It's also part of a defense response pathway. So just for illustration, I'll just pick that and I'll say that this is in the cytosol. Okay, and then I can add that and it will automatically create this statement in the graph editor, right? That there's a function enabled by a gene product, occurs in a cellular component, part of a biological process. Now, one thing you'll note here is that we didn't put any evidence on. And so to put evidence on things in the graph editor, you actually have to click on what at this point are empty boxes here. They don't have a green and an E in it. So to do, if you want to add evidence in the graph editor, click on that. And it will open the same kind of pop-up that you saw before when I was illustrating the evidence that came on from the from using the form. But you would add your evidence here. So I can say it's a direct assay used in manual assertion, and I'll add my PMID, and I can add that. If you have a with from value to add, it goes here, or like you can in the form, you can also clone evidence in the graph editor as well. So if I add that, now you see that the evidence is filled in. All right, and just so quickly, now I'll clone one for this. And so here's the list of what I've used so far in this model. If I want to clone it, I can just add there. And then I'll do for my process, and I will add that. Okay. Now, in the graph editor, it's really important that you save your work early and often. And so to do that, go up to this model drop-down menu here, and then go to the very bottom and hit save. And that will make sure that the work that you're doing.
Just a small question. I think you need a name before you can save, huh? Or you'll get an error message maybe.
So if you start, if you start with the form, it will automatically give your model a title, right? And then you're okay. But if you start with the graph, you've got to add your title. And so to do that, again, you would go to the model menu. You can update the title here in the edit annotations or give it a title. So in this case, like I said, from the form, it will give you a default title. But let's say I didn't have a title. So I'm going to remove this one and we'll add a title. So I'll remove it by clicking on the X. Okay, and now you may have noticed down here that there was a title and now there's nothing there. So let's add one, and I'll add it here. And then just add. And now your title has shown up there, your new title. And again, go back to the model menu and save. So a couple other things, you can, if you want, specifically just add a function here in the graph editor, or if you want to just add a process known, you can do that. You can also add specific, what we call individuals here. And so if I wanted to add, say, a cell type, I would do it in the add individuals, right? And so I'll just add, say, a sensory neuron. Now, sometimes in the graph editor, you may want to say, I want to link up the cytosol here to the sensory neuron. So essentially what you have to do now in the graph editor is kind of explode out the different pieces of information in your model. You would do that by going to View, going to the compact evidence folded. And then what I'll do is the way we make relations between nodes in the graph editor, click on the blue circle and then drag the box till you highlight the next thing you want to connect to. This will open up a pop-up window with all of the relations that we typically are commonly used for GO-CAM. So you pick the relation you want to use from the menu. In this case, I'm going to pick part of, and then save. And then, like everything, I won't do it right now, but you would want to add evidence to that statement. So then if I want to go back, I can fold everything up again, go to View, go to Editor, Folded for curation. Okay. So let's say we wanted to actually make a causal relation between activities. So to do that in the graph, we'll do the same thing as we did for the cytosol and the sensory neuron. So go to the blue circle, and I'm going to say I want to link up these two different kinase activities, right? So drag over to the activity I want to link it to. The relations box will come up again. And so let's say I want to say that this is a positive regulation. And so I'll select that from the menu, positive regulation, and then you'll actually see that you will have added that causal relation to your model. And same thing, again, you'll definitely want to add evidence to that edge. And I will save. So let me just also show a couple of tips and tricks. So behind the scenes for GO-CAM, there is actually, there are some computational rules for how the models should be made. And so you can, while you're working, click on the reasoner, and that will tell you whether or not there are any logical errors. Say, for example, and I can illustrate this, you know, if I were to say that a defense response was part of a sensory neuron, it would flag that as a logical error. And I'll show you what happens. In this case, there aren't any logical errors, so the background is green and everything looks okay. But let me make, specifically make an error so you can see what it looks like. So I'm going to say defense response is part of a neuron. Okay. So the graph will let you do this, all right? But then if I run the reasoner, you see that it turns red, right? Because I've made a logical error. A process can't be part of a particular cell. So what we've been working on is trying to, rather than, you know, just have this glaring red background image when there's a logical error, is to also identify, particularly in the model, where the problem is. And sometimes if you're working on bigger, larger models, it's not always immediately obvious, right, where the problems are. And so this highlights that it's the defense response is where the problem is. And there are some, what are right now sort of computationally friendly error messages, but Ben Good and Lauren Philippe and Tremaine are working on translating these into more curator friendly messages that will tell us if we've made this error exactly what is wrong. If you find that you're getting errors like this in your models and you're not sure how to interpret them, by all means, feel free to make a ticket in the Noctua tracker or get in touch with me or with David and we can help you sort it out. But coming down the pipe for development would be more user-friendly messages. A couple other things I'll just highlight in the
So Kimberly, I'm sorry. In this case, then, let's say if you only knew in which cell it was, you would have had to connect it to like the root and then connect it to the neuron. Like,
yeah, so say if you
allowed in the older version of checks.
So in the so you're saying you might know cell type but not component.
Yeah, right.
Yeah, yeah. So what I would do, what I would recommend that curators do in that case is exactly what you said. I would put in a root for component, right, as a placeholder, and then connect component to with a part of relation to the cell type. Yep.
Can I just ask, I know I've asked this before and I can't remember the answer, why it shows annotations 3 everywhere?
Oh, so that's the basic metadata that goes on every statement, right?
Is it useful to show that to the user?
Yeah.
I always find it confusing because I always remember in the end, but I'm thinking, I'm looking and thinking, well, where are the 3 annotations? Because it's in its annotations in completely different context to the annotations you're making.
That's right. That's right. So this is really owl speak.
So why not display it?
Well, I think if people find that confusing, we can think about taking that out. But really, what that
go on.
What that tree refers to, right, is my ORCID, the date, and the group.
So it's completely irrelevant to building the model here, and it would be just less words on the page, basically.
Well, less words, I'm not sure. I mean,
well, every box would be a little bit smaller.
Well, yeah, it seems to me we need the little evidence green box, because like also what I find super confusing about this is the evidence you add manually, but the ORCID and the other thing, the date, this is like just entered by the system. So this is not anything you do, and it's mixed with stuff that you do and stuff that the system does.
Yeah,
Whereas
so
the little green box for me is, well, once you know what it is, because it's very discreet at first, but at least you know that, okay, this green box cannot be empty. But I think we're not doing so much work.
There's also the numerator and the fraction there.
Mm-hmm.
Yeah, I know, but you only aim to have one, right? So, and I saw before we really had 4 out of 3 because she added 2 evidence. But so I don't know, like for me, like I would expect, you know, if this was addressed to me, I would expect I need to add 3 out of 3.
No,
but I only need to
it really refers, yeah, it really refers to different things. So I mean, we can think about how to make this a little clearer. And I also think once you use it a little bit, you just start to get used to what this means, right? And it is somewhat owl speak. So the 4 in this case refers to the actual 4 pieces of evidence, right, that I added, right? And
which 4?
So now it's not counting the date and the ORCID anymore.
No. So they're different things, right? So it's not really like 4 out of 3.
If you just got rid of the thing that isn't something the user has to add, it might be a little bit clearer. But to me, I didn't even realize what the 1 of 3 or 4 was. It just didn't. Do you even need the numbers? Do you not just need a flag that says you need a piece of information here?
I guess that's something that we can get more feedback on. Yeah. But yeah, it really refers to 2 different kinds of sort of metadata that's put on.
That's confusing in itself, because the numbers, to me, the numbers aren't useful to me while I'm doing this at all. But I didn't really know what they were. But even now I know what they are, I don't see how they're useful when they combine things that I don't need to do with things that I need to do.
If you see a 0, though, you need to put a piece of evidence on that.
Yeah, if you see a 0, you miss something.
Right.
Yeah,
Why
maybe the second number is too much.
Like you've made something that should be really simple, like you've missed something really complicated by saying 0 out of 3, like 3 what?
So Tanya has her hand up.
I think you've just got used to it.
I'm sure we have, but also there's a method to the method.
And that's not a real, but being used to it isn't a good reason to have it like that.
So Tanya and Ruth have their hands up.
Okay, Tanya?
I was wondering, just kind of on the bigger picture of the display on the page, I noticed that we see both innate immune response and part of twice, right, in the upper right-hand section of the view that we have. Have you thought about kind of consolidating that display so that you just see that box once, and then you have both PMK1 and ATF7 connected to it by part of?
Absolutely, yep. And so
that would be better, and also to put those on the defense response, to have that to have any connection in the ontology already there would be helpful.
Yeah, so I think that's a separate ontology issue, right? So this is just for illustrating Noctua. So the answer to your question, Tanya, is yeah, absolutely. And we've talked a little bit about that in the GO-CAM modeling group of, you know, when to do that. To be clear, it's the same thing. We could at this point. This is just a slightly different way of representing that, and maybe computationally that's something down the road that we could automatically do.
Yeah, I think it's really important to point out here that the graph viewer has not been optimized. And so just think of it right now as the main thing it's going to serve in your workflow is it's the easiest way to connect up activities. And we're really aware that the view isn't optimal right now for that, but at least, you can find your activities in there. You can see the gene products. It's going to, and how it maps to, as I had said, that sort of sketch that you had made earlier in the process. And so here really, don't worry too much about trying to read the graph. Just find the activities that you want to connect and connect them up. That's really what this tool is for. And we're very aware that we can do more work to make that easier to do.
Right. But as far as display is concerned, aren't there some resources that display the graphs already as models? Or not? Can't you view these graphs online?
You can view them in the workbenches, you mean? Yeah, you mean you can get a different, like a Cytoscape view, you mean?
No, maybe I'm now dreaming this, but I thought that there were some resources like, I don't know, maybe MGI that displayed these graph views?
No, as far as I know, the only one that does is the GO-CAM browser at Go. We don't display them at MGI for sure.
Okay.
Yeah, so just remember at this point you're curating it. It hasn't been released anywhere, right? And so what you'll do is you can go up to the workbenches if you want a different view of it. But really at this point, just think of this interface as just use it for connecting things up. That's really what we're recommending at this point. And we'll clean up the view a little bit, but it should be adequate just to find the activities and connect the activities up. So just try to focus on that for now.
Right. So what, for example, I did between the NOSI1 kinase activity and the PMK1 to put that causal relation between them. That's really, I think, the main thing that we will do with the graph editor. Okay, Ruth, did you have a question too?
Yes, hopefully. Am I speaking? Oh, yes, good. I was just I realized that you don't want more feedback on how this view looks, but I was just trying to confirm that I agree with Val, and that having, if you want to write in that your metadata is 3, maybe you should write it in as metadata, but as 3 is present in everything, it seems like it would be more, and also the fact you've got the E in some of the boxes, and then in other places you're expected to know that the evidence is the 0/3. It just feels like maybe if you want to use that space, either put it as, instead of it being 0/3, you have that little empty box, and then when you put evidence in, it becomes an E in the little box, and then you would see E all over, and it would be sort of standardized. That was all. But,
okay. I am taking notes.
Yeah, that would be really helpful.
Okay. Yep. I am also taking notes. So, like I said, we hope to be able to do a lot more work on the graph editor in the coming year. So, I will. Yeah.
Yeah. So when you put the positive regulates between the NOSI1 and the PMK, do you assume anything about the neuron, the sensory neuron? Do you assume in the PMK1 the activity is also in the neuron or not?
So I think in this, yeah, it's a good question. I mean, I think if I were making this model for real and not just as a demo, I think if I was going to make that statement, I would want to make sure that the PMK1 was also in the sensory neuron. Yeah.
Okay.
Yep.
Yeah, because many times, okay, yeah, but this is for yeah, paper by paper is different. If for yeah, the process maybe. Yeah.
Yep. Yeah, but that's a good question, Lee. Okay, and so just a couple other quick things to point out. So like I've said, there are other functions that we have in the form. So if you wanted to toggle back, you can either go to the Noctua form. I have it open here as a tab, but there's also an option from the workbenches, and you might particularly want to use this if you started your model in the graph and then wanted to go work in the form as well. The annotation preview, we'll open up a separate tab view that will actually show you basically a summary of the annotation, the conventional annotation statements that are being made from your model. So that can be kind of a nice preview of what might be coming from the GPAD output when you make it production. There's a nice cytoscape layout tool that kind of gives you a more compact view of the model. And then if you want, you can import function annotations from the graph with the function companion. And then there are a few other things like an inference explanations that shows you some of the logic behind the inferences that are made. You could create a macromolecular complex here if you want, or there's also a pathway view. I typically, when I'm working, maybe just use the form and the annotation preview. Occasionally I'll go look at the cytoscape layout as well.
So Harold has his hand up.
Yeah, just a comment that I don't know if people noticed. So when you showed the annotation preview, which I find useful, you see that they all had PubMed IDs. The annotation that you did not add evidence for, positively regulates, that didn't show up.
Right, right, and that's a good point.
Another, useful clue for you that, oh, I just made annotations and they're not there. How come? Oh, you forgot to add a reference.
Right, exactly. So anything, if you're going to have anything output in the GPAD, just like conventional annotation, it has to have full evidence with an evidence code and a paper, right? So if something isn't coming up and you expect it to, might be a good thing, right, to go back and just check and make sure that you have evidence on it.
So I'd just like to say one more thing about the display, because I don't think it was clear when I was saying about the processes. The innate immune response being part of defense response should be connected up. And then that was, I think, Kimberly, you said that's an ontology issue, but what I meant was if there's an existing relationship, because that is already part, innate immune response is part of defense response. If I was curating a process and then I was curating sub-processes, which this kind of is, I would want to see, so that I knew I'd got things correct, that defense response was a parent of, was already part of immune response. So if I had two terms that are related in the ontology already, it would be nice if that part of showed up, because otherwise I'm going to have to add it to make my model make sense as I curate sub-processes. Does that make sense?
Yep, yep. And I think there's actually a lot that we can do with things like that, Val.
I mean, anywhere where you're doing something that already exists somewhere. And also it would be a good check that people would know, right, yeah, I'm annotating, because otherwise why are they even in the same model unless the connections that already exist between the processes show up?
Yeah.
And usually you wouldn't connect, you wouldn't annotate a term and its parent most of the time.
No, but what I'm saying is because defense response is, so innate response is part of defense. So sometimes this is probably not a good example, but yeah, innate response is part of defense response.
No,
so
of course.
It's a typo.
It's a typo?
Yeah, I think it's an assumption. It's not a part.
Oh, yeah. So I think that
it's
summarize, Val. I
oh,
think
right. It's because it's ISA. That's why you wouldn't see it. You only show part of.
Well, you don't. I don't think you would see the part of either, even if you put it in there. But in this case, it's an ISA.
Yeah. So
if you were curating a pathway, for example, that had separate parts, so for example cytokinesis, and then you were doing the parts like cytokinetic ring assembly, ring constriction, you would want to see the cytokinesis parent, and then you would have branches with the separate parts where you'd have the connections. Wouldn't you want to see how those, would you have to put you'd have to put your own part of relationship between all the parts of cytokinesis and the parent term. You'd have to put those in
Yeah, I
yourself.
think that's
See
really
it,
interesting.
So
you
you'd
would,
almost be you'd be putting in, maybe you don't need to do that.
Yeah, I
I
think
don't know,
it'd
I'm
be a
just-
really interesting question though, Val, is that maybe, you know, and one of the things we could do is, right, use the ontology, right, to seed models, right? And then those, if we wanted to annotate parts of a larger process, we could possibly seed it with what's in the ontology, and what curators could do is come in, you know, and add the specific evidence in gene products for that. And I think that would be, you know, a really nice feature to have.
I think it would be a beautiful feature. And the other thing though, Val, to be aware of is that if that relationship exists in the ontology, even if you don't see it on the graph, it still exists, right? The ontology
It
is,
would be useful to see it on the graph, like it
it would be incredibly useful to see it on the graph.
Sometimes, I mean, some of those ontology hairballs in the quick view of a process, you really don't want them in your graph.
Oh yeah, you don't want to see everything, but if you put two terms and they're connected, I think it's interesting to see the connection. But I agree with you, you don't want to see the full path to the root.
Right. What if there's 3 or 4 steps between an innate immune response? This actually, if we made it a more specific kind of innate immune response, it would have a parent innate immune response, which is a defense response. You want the whole path in there? I mean, this needs some more. This needs some more playing.
Yeah.
I mean, remember, this isn't the trouble with having this picture, is that it reminds us how limited the form-based view of Go curation is. I mean, we're suddenly able to show relationships among parts and kinds that were always there, but we were working bottom up. And now there's this option of seeing the whole landscape, and we've got to figure out how to use that. And 2 things, and that breaks into 2 questions. What do you want to, basically, what parts of the landscape do you want to compel curators to include? So by default, these things should be linked to one another. Or if I put this kind of thing in my graph, then this other kind of thing with the appropriate edge connecting should show up by default, versus what kinds are options for curators to put in, versus probably there are relationships that we would want not to make it very hard or impossible for curators to put in.
So do the checks allow you to put relations that are in contradiction with what's in the ontology? So for example, if a defense response is an immune response, for example, can you put part of, and will this get?
Yeah, so I think, yeah, these are all really good questions, but maybe a little more advanced than what I intended with just showing how to use the graph editor. So I think
I really want to encourage people to focus on the workflow that I tried to map out in those first couple of slides, right? Which is, you know, use the form to build the activity unit. Okay, and so now you can see the activity units. They're not pretty, but at least you can locate them, and then in this view, try to link them up. Right. You know, doing all the checks on your models. You know, we can talk about how we can help do, you know, quality control and find mistakes. But just think about right now. Just think about the process of doing it, and then we can get to sort of, you know, things that people think that we can add later on to make the process easier. And I think, you know, I just wanted everyone to be aware that, you know, we're already aware that we could make this view easier to deal with and make it easier to find the activities and link them up. But at least you can do it now, you can find them, and that's really what we want to emphasize at this point, and we can get to improvements later on.
So if I may, I also have 2 comments to add up. The first one is, anyhow, the data is here, so it will be easy to evolve later, and it will not really involve curator work except feedback. The second one is, actually, we do already have a view that may answer more or less that issue, that immune response is already a part of the defense response. And it is by grouping the activities together in boxes, and those boxes represent BP. And then you could have several boxes, the first boxes being the immune response and grouping the 2 activities, and a larger box that will encapsulate both. So there are ways to deal with that. But
Are you talking about stuff that's being developed, or this is just like one possible solution?
no, I'm just giving perspective here. Actually, no, there is something in the Workbench Cytoscape tool, maybe we can see later during a hands-on, where you have a nested option that kind of try to do that.
Okay, okay.
Yeah, but I think, yeah, just to reiterate what Paul said, for the purposes of the Jamboree, right, what we really want people to take away is that you can connect up your activity units using the graph editor. And right, we know that there are things we would love to be able to do with the graph display. I've been taking notes through this whole section, so I've got people's feedback here. And so, yeah, hopefully in the future, what you see here maybe will either be a little bit more intuitive or, easier for people to work more efficiently. So that was about it that I had just for introducing the two user interfaces. We have a break in the schedule right now, so I was going to suggest we take about a 15-minute break.
So Kimberly, Harold still has his hand up.
Oh, I'm sorry.
Oh, sorry. No, I thought it went down.
Okay.
I'll fix it. Sorry.
Okay, so let's take about 15 minutes. And so we'll come back at 20 past the hour.
Thanks, Kimberly.
Okay, thanks.
Thanks.
Great. Thank you, Susie. Okay. Okay. So we've gone through this first part of the talks for today. And so for this second part today, we thought we would go through specific example models to illustrate to curators, how we're thinking about modeling different areas of biology. So David, myself, and Pascal will each present a model of a particular area of biology that we've made and we've discussed on the GO-CAM modeling group calls. And so this hopefully just will give enough illustrative to help get people started on making your own process-centric models. So David's going to start first with some models of metabolism that he's been working on. So David, I will turn it over to you.
Right, thanks, Kimberly. So I think I may have gotten the easier task here doing the metabolism models, but we'll see. So I'm going to tell you a little bit about what I've been doing to make some decisions in my workflow for making metabolic pathway models in GO-CAM. And I've been working very closely with Peter. You'll see why in a few minutes, and with Kimberly, bouncing off ideas off of them about how to construct these models. And why am I not? So this is just an overview of my workflow about how I go about making metabolism models in GO-CAM. So the first thing was to identify a pathway. And we chose a pathway that has clinical significance and that we knew differed between mouse and human. So this, Peter suggested this. This is the purine catabolism pathway. In humans, it ends at a different point than it does in mouse. Because humans actually, one of the genes is mutated and it's become a pseudogene and it's non-functional. But once you've identified a pathway, the next step is to go find the biological process that represents that pathway. And what I've found just from doing these kinds of exercises is that leaf node processes are the best to model. They're usually a very good chunk of metabolism that's easily manageable that you can make a model from. And then I go out and I find existing information about the pathway, and I use a lot of different resources for that. I primarily use Reactome. The reason for that is because we are involved in another project where we're actually importing Reactome human pathways into GO-CAM models. So it's become very easy for me to look at Reactome, look at a GO-CAM model, and then create a mouse GO-CAM model based on the Reactome human model. Some other pathway resources that we've used in the past when we've been doing ontology work with metabolic pathways is Metapsych. And then something that's really interesting that I find when I'm trying to decide what the limits of a pathway are is to do a Google image search. And what you'll find is 9 out of 10 of the images start here and end here, right? So that's a kind of, all pathways are human constructs, but that's kind of the way that I decide where my pathways begin and where my pathways end. There's a couple of other aspects of things that I use but for the most part, if you do an image search, you'll see that people think about pathways pretty much in the same way. Then I create a draft pathway where I have molecular functions, cellular components, and the biological process in that draft pathway. And then I add the genes to those molecular functions. And that can be done with imported functions that already exist as annotations into the database, or you can make those enablers de novo based on what you're finding as you're looking at the pathways out in the literature resources. Then the last thing that I do is I add the remaining relations between the molecular functions in the pathway. So causal relations from one pathway function to the next pathway function. And then I make all those functions part of the process that I'm modeling. And then I make each of those functions occur in a component. Once that's up there, that's kind of a straw man pathway. And then I go in and start to fill in the remaining evidence. The first 5 steps here are actually pretty easy. You can use Reactome, you can use other resources to basically generate pathways on a GO-CAM canvas. Finding the remaining evidence is the hardest part of the whole process. So if I want to find specific evidence for enzymes in mice, it's often challenging to go back and find those original papers. Okay, so first step is finding information about pathways. So I just have 3 examples here. One of them is the reactome view here that I use quite a bit, probably more than anything else. I use reactome, but there's also metapsych pathways that you can look at. And then these are the Google images, and you'll see most of these images go on, start at one place and end at a place, and they're reasonably consistent about how the different images represent pathways. So that's just kind of a sanity check that my pathways starts and stops are in the right spot. So the next thing I do is I take all of the molecular functions that are associated with that pathway. And in this case, I took the molecular functions that Peter had already curated for the human pathway and reactome, and I throw them on a canvas. So I have 5' nucleotidase, ADA, and all of the different molecular functions that contribute to the breakdown of AMP in a mouse. Then I put the 2 different components. These happen in the cytosol and the peroxisome in the mouse. So this is just a sort of a very, very basic beginning canvas of these are the enzymes that are involved in this pathway. This is the pathway, and this is where these enzymes act. The other thing that I do that's a little bit challenging is I try to put these on the canvas in the order that they occur in the pathway, because in general in metabolism, we tend to think about metabolic pathways as the way the metabolites go through the pathway. And so in this case here, the metabolites aren't listed, it's just the molecular functions. So I put those molecular functions in the order of the way that I know that the metabolites flow through the pathway on the canvas. Then I add the gene products to those functions, and there's a bunch of different ways that you can do that. The first thing is I look in MGI to see if their annotations have already been made for those gene products and those molecular functions. I then can use the Noctua form that Kimberly described to import those functions into my model. If I don't find reasonable information in either of those ways, or I don't find existing annotations, again, I go out to reactome, and in this case, I've looked at the orthologous pathway that reactome has predicted for this enzyme, and I find the mouse entity there. And then I go out to the literature to see if I can find evidence that that enzyme, that gene product actually enables that enzyme activity. Okay, adding the evidence, again, I said is the most challenging part. I usually start right at MGI. I do a literature search on the genes or the molecular functions that I've assigned in my pathway diagram to see if there are uncurated papers in MGI that provide the evidence that I need. If I strike out that way, the next thing that I usually do is a PubMed search looking for original papers that support that the mouse genes enable those molecular functions. And then finally, sometimes I do Google searches as well to try to identify papers. And again, my workflow is my workflow. Other people may have different ways of identifying literature. I know the Alliance is working on ways to identify literature for curation. This is just the workflow that I use. If we've got it in MGI, I know I can get a hold of the paper and look at it. Next to use PubMed, and I look for free PubMed central articles or ones that we subscribe to in our library. And then finally, Google Scholar searches. So the idea is to just find some piece of experimental evidence that supports the annotation that I've made as a strawman annotation in the model. So I'm going to show you a couple of the models that I've made. So the first one is mouse AMP catabolic process. The model starts over here with a 5' nucleotidase activity, and it flows through a series of molecular functions. And you can see that this model actually branches. There are 2 different activities that can take the output of the PNP, the phosphorylase activity, and feed it into 3 different aspects of the next molecular function downstream. Then at the end of the day, humans would end here because they don't have urate oxidase, but mice have urate oxidase. So these 3 molecular functions can feed an input into the urate oxidase activity, and then 2 successive enzymes continue to metabolize the uric acid all the way down to allantoin. So I basically put all of these molecular functions into the pathway. I decorate those with different pieces of evidence, and then I decorate them with evidence as to where each of those molecular functions occurred. Originally, I had actually put the process on a cellular component, but I find that with respect to evidence, it's actually easier to put the evidence on the molecular functions because it's difficult to put an experimental piece of evidence on the process itself. So it was much easier for me to find evidence for where the molecular functions occurred than to find a good piece of evidence for where the entire process occurred. This is an example of deoxy-GMP catabolism. And one thing to note is that if you look at this right-hand half of this pathway from xanthine dehydrogenase or oxidase activity to the right, it's the same pathway, right? So as these nucleotides get catabolized, they eventually feed into a common pathway that uses xanthine and eventually has an output of allantoin. So these molecular functions are actually redundant annotations from pathway to pathway. And later on, we can discuss the best ways to do that. I actually just by hand copied all of these, but as Petra said in one of the earlier talks, it would have been really nice if I could have just taken these and cloned them one by one into this model, because it's the same function. It's it's the same gene product that's enabling that function, and it's the same evidence that gene product enables that function. And then upstream is where the pathway differs, right? So that in this case, in the case before, you were using adenosine and feeding it into the pathway through hypoxanthine. In this case, you're feeding guanine into the pathway.
David, can you just go back to that just 1 second? What's so when you do that branching at guanine deaminase, why do you have two xanthine oxidases again?
Because one of them is in the cytosol and the other one's in the peroxisome.
Right, it's the location. Okay, got it.
Yep.
And so in that case, yeah, okay, got it.
Yep.
Sorry,
and the evidence in mouse that it exists in the peroxisome actually comes from a rat paper. And it's still, I think, quite controversial about whether or not xanthine oxidase in a mouse can occur in the peroxisome. Apparently it does in plants, but biochemically it makes sense. And I don't want to go down into the weeds, but it does make sense that it could occur in a peroxisome in mice as well. Generally it's clear, it's been shown that it occurs in the cytosol, right? And then, and then the xanthine dehydrogenase. So it's an incredibly fascinating enzyme. It can either use oxygen here, and then it outputs hydrogen peroxide, and you have to get rid of the hydrogen peroxide, or it can use NADH here. So it can use either one of those two to accomplish the same reaction metabolically, basically. So it's a very cool.
So it's the same gene product, but it has two different reactions and two different locations.
That's correct. Yes.
Okay. Got it.
It's really cool. All right. So what are the benefits of doing this kind of curation from GO-CAM? So the first one is it allows you as a curator to focus on a single area of biology and become very familiar with that area. I found that when I was doing this, reading more than one paper or reading more than one review is critical, because everybody writes with a little bit of bias, and you kind of have to synthesize all of those different views together for your model. So for example, the xanthine oxidase in the peroxisome, I probably would have never found if I hadn't been sort of, going down and reading more than one paper about how this process occurs. And it wasn't until I started looking at papers where the cells were responding to oxidative stress that they started focusing on the xanthine oxidase aspects of this. And my strategy that I used in this was to capture redundant evidence if I was reading the papers anyway. So if I found, I may have been looking for evidence for one of the enzymes, and in that paper that had evidence for one of the other enzymes in the pathway, I just went ahead and captured that redundant evidence because I was looking at that paper. But the most time-consuming aspect of the process is definitely finding evidence. And the Alliance Working Group is working more efficiently on ways to categorize papers so that we can do this more efficiently. The other thing is it would be really nice to be able to clone subpathways that are the same, that are conserved between AMP, GMP, DGMP, DAMP, right? To take those conserved bits and be able to clone them from model to model. The one thing that I found, and I was a little bit surprised by this, is that it really fills in needed gaps in the annotation of metabolic pathways. And in the next slide, I'll show you what the stats are for that. And then once a pathway is complete, it can be used to seed other pathways. So it took me a really long time to do the GMP pathway. And then I did all of the other leaf nodes for the nucleotides using that GMP pathway very, very quickly once I had done that GMP pathway. So my goal now is to sort of use this as a seed and then grow my plant out, right? So I did all of the nucleotides now, but there are other biological processes in Go that I can now look at and say, oh, look at this one is really close to this. So I know a lot about this. I'm going to expand this now into another model. In one case, I did that already with AMP, but I'd like to do it with the other nucleotides as well. And the other thing about this is it obviously it allows you to develop a causal path through metabolism. And rather than having individual annotations, this may shed light on why errors in metabolism manifest themselves in specific diseases, right? So a couple of diseases that just come to mind are gout, which is this purine catabolism pathway. Tay-Sachs and Sandoff disease is problems in the nervous system. And diabetes, of course, is metabolic syndrome, is glucose metabolism. So just a little bit of metrics. It took me about a week to do these pathways, far from full time. So for those of you that know Kimberly and I, we spend a lot of time on telephone calls. So it was between those calls, probably one Friday, a Monday, Tuesday, and a Wednesday that I did these pathways. The top part of this slide these are the pathways that I created as GO-CAM models that are production pathways. And what you can see is once I did GMP, it was pretty easy for me to do DAMP. It was pretty easy for me to do IMP. And then since I couldn't find evidence for some of the mouse enzymes for the AMP, I had to do ISOs to rat. And so I made a seed pathway for rat, where I put a few of the enzymes for rat in that seed pathway. And then for the different substrates of PNP, I couldn't find evidence in the mice for those. So I actually created a small human GO-CAM model for PNP being able to act on all of those different substrates. I did do a second AMP catabolism model in mouse. And the reason I split it out from the original model was because in this case, the AMP is the first couple of steps of that catabolism. It's happening extracellularly. And so the cool thing about that is it's not only are you catabolizing this AMP to adenosine, but in some cases that adenosine's transported into the cytosol where the other enzymes can work on it. But in other cases, it's used as a signaling molecule. And so I thought, you know what? I'm going to split that out as its own model, because at some point I'm going to want to have that causally upstream of adenosine signaling as well. But if you look at what existed in MGI before I started the project, so for IMP, we had no genes and no annotations. DAMP, we had no genes, no annotations. GMP, we had 2 genes and 2 annotations. AMP, 1 gene, 3 annotations. And DGMP, 0 genes and 0 annotations. And so I made a total of 8 models that represented these leaf node processes for nucleotide catabolism. And you can see that I started with DGMP. So there's 44 annotations that come from that DGMP model. The AMP model, there's 32 annotations, but beware that some of these are duplicate, because when I first started doing it, I basically copied everything, including the evidence that this gene product enables this enzyme activity. As I started doing it more and more and just sort of cruising through things, I didn't copy the redundant annotations anymore. I only evidenced the annotations that would make new annotations in MGI. So most of those were process annotations that, yeah, this enzyme is involved in not only in catabolizing GMP, but it's also involved in catabolizing IMP. And then of course, if there were different enzymes involved, those got fully annotated as well. So a total of 166 annotations after less than a full week of annotation, I think is pretty good, with the caveat that some of them are redundant. But the nice thing now is that we have a full representation of each of these leaf node processes, at least for one way the pathway can work in MGI. Now, if I go out to Reactome, there are other enzymes that can feed into some of these, and I haven't exhaustively done that yet. I've done it in a couple cases, but not exhaustively. But we have a much better representation in MGI of these catabolic processes than we originally did. And I believe that's it.
So David, when you said that they had 0 annotation, you mean 0 experimental, or they didn't even have Paint or Interpro?
0.
Oh, wow.
0.
That's surprising, because you would think they have domains. Nice.
Yeah, well, so the molecular functions were often annotated, but they were not annotated to the process.
Yeah, okay.
Right?
Thanks.
And so it was really interesting, Pascal, to see that, because what you'd see is that, like, for example, xanthine dehydrogenase would have a molecular function annotation, you know, sometimes from Paint, sometimes from experimental, but it wouldn't be associated with the process AMP catabolism, right? It might be associated with nucleotide catabolism, but it didn't go down to those leaf node processes that this annotation allowed us.
Oh yeah. Okay.
So I hope that makes sense.
Yeah, definitely.
Anything else?
Yeah,
Ruth.
any other questions for David?
Ruth.
Yes. Sorry, I was wondering, because obviously Reactome data is coming into the GO-CAM models, and I just wondered how these were represented for the human in GO-CAM models that were imported from Reactome.
Yeah, so almost the same, but not quite. So if you're interested in looking at the Reactome models, Peter and I and Kimberly, we can sort of give a little tutorial about the best way to look at them. So it's not exactly the same, but it certainly is close. So one example of where it's not exactly the same is in my AMP model. I've included the enzyme adenosine deaminase as part of AMP catabolic process. And Reactome, that enzyme is in the salvage pathway. But Reactome does have a causal connection between that enzyme and the catabolic process. And so Ben has included those causal connections. And what I ended up doing is just sort of tweaking the boundaries of the pathway a little bit from the Reactome import.
Yeah, yeah. No, I just wondered because, you know, again, this comes back to this idea of having a template, you know, that maybe if you'd had it as a template and then you could, you know, it might have helped, but maybe.
Yeah, it certainly would have. Yeah, and what I would have loved to have been able to do is to go into the Reactome GO-CAM import and just like click on the enzymes that I wanted and say, bring these over, or even look at the Reactome mouse ortholog projection, right? It doesn't go all the way to allentone, it stops at uric acid. But you know, that's the kind of thing in the future I think that will really streamline the ability to make these models, is to be able to go to someone else's model or another model and say, these are the parts that I want, and I'm going to take them and put them in my new model.
Yeah, no, well, that sounds great. I mean, I'm just wondering whether, you know, this whole thing that we started many, many years ago with the reference genome, you know, but that idea of different groups actually just saying, look, I'm going to try and deal with this, rather than everybody just going off on their own.
Yeah.
It's difficult to have that communication, I know, but, you know, it was interesting. I was just going to say, it was interesting when we've been doing some annotation and we discovered that actually, you know, we'd assigned certain genes as important to curate, and then SwissProt decided they needed to be done as well.
Yeah.
And we ended up in the same week annotating the same gene, which just seemed completely crazy that we were looking at the same papers at the same time.
Yeah, yeah. So that would be, it would be interesting to sort of put together a workflow like that if we were interested in curating the same areas. So the other thing that I wanted to say about Reactome is that Reactome uses sets. So I don't know how familiar you guys are about Reactome. So some of those enzymes that are in those pathways can use different substrates, right? They can use GMP, they can use AMP, they can use IMP, inosine. Reactome would make one reaction for those and create a set for those imports. Okay. In Go, we actually have separate catabolic processes for each of those. And so I ended up taking a pathway that was basically grouped in Reactome and splitting it out into separate pathways in Go that represented each of those individual molecules that Reactome had as a set.
And then you have to wonder, when people do an enrichment, did they need to know that?
Well, that's interesting. So
how many different proteins are associated?
You can justify anything, right?
Well,
and I thought, well, you know, in Reactome, you could ask, you know, what in this reaction, can it take any one of these? And you can answer, yes, it can take any one of these. But then in Go, you could specifically ask, well, I'm really interested in adenosine signaling that's downstream from that. So I only want to look at the adenosine.
Yeah. Right? No, I'm just thinking with your grouping, if you've grouped it, that you had like maybe 10 proteins at a maximum, that if it had just one protein difference or 3 proteins difference, whether really you know, an enrichment tool would identify the different pathways based on just one protein, you know, difference or whatever.
That's a really interesting question. It should be easy to ask. Yeah, I'd love to like explore stuff like that.
Yeah. Anyway, it's very, very impressive. And I just like the fact that you're finally doing process, which obviously I've been doing for 12 years, you know, I mean. My model forever.
The same kind of process as you're doing.
It seemed to me when I first started that working on a process, you know, it's completely ridiculous that we're expected to understand the whole of biology and change subjects from one day to the next. And, you know, it's really nice to see that you're enjoying it.
Thing. Yeah, and you know, I'm sure you find this too. That was the thing that was satisfying about it, was because I felt like, okay, I really understand what's going on here. You know, I really understood the difference between the urate oxidase and the urate dehydrogenase and what was going on in the cell and what was happening downstream. You know, I may not remember any of this stuff in a month, but when I was working on it, I would read a paper and I knew exactly what those guys were talking about. So it was quite nice.
Yeah. No, I completely get that. And I think it's unreasonable to be expected to cover the whole range of biology. But anyway, I'm just showing my face as well, because, you know, I just suddenly realized you're talking to a black screen and it's very simple. So anyway, it looked beautiful. Thank you, David.
Yeah, Ruth, I think you raise a really, that's a really important question. I think it's something that Judy has been wanting to discuss amongst the Go annotation group is, you know, going forward with our annotations, right? What really makes the most sense for us to do as a consortium, and right, how can we leverage off maybe individual expertise and use that to expand what we have for all the organisms, or as many organisms as we can.
Yeah, and it was kind of, I was actually shocked when I did the annotation counts, because in general, we think, oh, gee, we have a whole bunch of genes out there that don't have any annotations that we don't know anything about. But what this showed me was another way to approach that, is to say, we've got a lot of processes out there that really need a lot of genes annotated to them that aren't there. And so it's kind of a whichever way you want to approach it. That's, you know, I think they're both valid. The other thing that I didn't mention is I don't tend to use the form, and I think that it's just the way you visualize stuff. I tend to use the graph all the time, and I watch Kimberly use the form, and it's so incredibly efficient, but in my mind, I see it in the graph, and so I use the graph.
Yeah. No, I mean, it shocks me all the time when I'm doing the processes. We started looking at cell adhesion the other day, and it was just like, seriously, seriously, this is, you know, we haven't got this covered. There's so many things missing, which, you know, it just feels like it's just this massive mountain that we're trying to tackle. And yeah, it would be great if we could feel that, you know, the annotations you've done for mouse, they can now go to the human and to all these other species. So I don't have to worry about doing those, you know, they're covered, and you should, you know, we should feel like we can, you know, take advantage of each other, as you say. I think that would be an amazing advance to make. Yeah.
Colin, you have your hand
I can only say lucky you. Hi, organisms.
Well, you know, I have to say, Peter can tell you, I bounce a lot of stuff off of him because he knows biochemistry so incredibly well. So I'm constantly sending him emails. Hey, I have this paper here. You know, what do you think of this? So I do have the advantage of having someone who is an expert who's an email away from me.
Hi, so yeah, fascinating and fantastic. I really enjoyed. I had a question for you, David. It's you talked about seeds, and so I was wondering, is this then your canvas with the molecular functions, or what did you really mean by seeds? Because this sounds very close to the cloning I would like to be able to do.
Yeah, and I think it actually is. So the right-hand half of each of those models, there actually is a Go process that represents that, and that's xanthine catabolism to uric acid, right? I would love to be able to take that half of that model and say, okay, this is going to be a seed now for every single one of my nucleotide catabolic process GO-CAM models, and then just add the things that are different to that seed.
Okay, so very concretely, if I would change I would save my file under a different name. I would not keep it under the old name in its, let's say, more diminished version or in its more primitive version. So is it really not possible to just have these molecular functions that you had in your first canvas and to save that and then to elaborate it, save it with another name and to be able to go back to the initial molecular function canvas?
So technically you can't do that. But we are going to be able to do that. That's one of the things that's high on the drawing board. But then the other thing that you have to think about is at least I think there's going to be cases where you want to duplicate it and say these are exactly the same molecular functions. But in other cases, say, you know what, maybe they're not. Maybe there's a paralog, right? So I'll duplicate all the molecular functions, but maybe in a different tissue there's a paralog that enables this. I want to be able to say, okay, I'm going to clone it, but they're not going to be exactly the same, right? So I'd love to have sort of that ability to pick and choose what I want, when I want to completely clone it, and when I want to copy it, but have a different, basically, I guess, a different example of it.
I thank you very much.
Yeah.
Yeah, just to follow up, I put a little something in the chat window on this, Colin. So we actually do have the software. Laurent Philippe has developed software to copy a model. So this is something that'll be available in the near future. So we're pretty aware that this is a useful feature, just to be able to copy it and then change it.
So that's correct. And just to add a little bit to that, so not only can you copy a full model with everything, or like it was suggested before, to copy the model, let's say, without a gene product and without the evidence, so that you could do it for another species. Another functionality that was discussed also a little bit before, I think maybe by Petra, is that you could be able to copy only part of a model. So all of that will be coming soon. Just question of priorities and putting it together in a nice UI.
Okay. Any more questions for David? All right. So then just want to pull up my model and then I'll slides. Okay, so can people see my screen?
Yes.
Okay. Okay, so I'm going to talk about a different kind of model that we've been working on at Wormbase. This is, in some respects, this is more like a signal transduction kind of model, but there are a lot of other interesting things going on in this model. So the one I'm going to present is the IRE1 mediated unfolded protein response. And a lot of the initial work that was done for this model was done by Marie Claire Harrison when she was at Wormbase. She's a graduate student now at Vanderbilt. And then also thanks to Paul Thomas and Paul Sternberg and everyone in the GO-CAM modeling working group for their input on this. Okay, so just by way of review, so the endoplasmic reticulum unfolded protein response, it's largely, but not entirely, a stress-activated pathway that responds to increased levels of unfolded or non-native proteins in the endoplasmic reticulum. And there are three main branches or signaling pathways that are part of the ER-UPR. There's an IRE1 mediated response, PERK mediated response, and ATF6. And each of these has different outcomes at the end of the signaling pathway. But the objective, of course, is to lower the levels of unfolded protein and restore proteostasis to the cell. If the ER stress is severe enough, the response actually leads to apoptosis. So these are well conserved, but the IRE1 mediated branch is the most highly conserved. And so that was the one that we decided to focus on for our modeling. And so this decision for us kind of illustrates one aspect of GO-CAM process-centric modeling that I'd like to emphasize, which is that you don't necessarily have to start with, trying to model the whole process. It is helpful, and I think it makes sense to sort of break things down into smaller, manageable modules that you can model. And then later on, we can start stringing these things together for a bigger picture view. So I'll just sort of quickly go over the activities that we are trying to model in this GO-CAM. So basically, there's IRE1, which is a really interesting molecule. I'll talk more about it later, but it essentially has three activities. It binds unfolded or misfolded proteins in the ER lumen. It's also a protein kinase, and activates itself, and it's an endoribonuclease. And it actually cleaves a messenger RNA for the XBP1 transcription factor. And that messenger RNA, after it's cleaved by IRE1, is ligated by a specific RTCB mRNA ligase that resides near the endoplasmic reticulum, that also can function as a tRNA ligase. So it's a little bit of an unconventional mRNA splicing event here. But once the XBP1 mRNA is productively spliced, then the XBP1 transcription factor can migrate into the nucleus and transcribe targets, which would be things like protein folding chaperones. It would then help alleviate the ER stress. So like David, this was kind of the workflow that we took when we decided we wanted to try to model this. And so we went to reviews in PubMed. We used Texpresso searches. We looked at an ER UPR model that some worm-based curators had made in Wiki Pathways. We looked at our existing Go annotations. We looked at Reactome as well. And we also went out to Google Images and looked there. And so then what we did is we were confident that we had identified the key players in this pathway. We looked for the C. elegans orthologs of each of those. We figured out what we thought would be the necessary Go terms, function, process, and component to make our model. We looked at what existing annotations we already had, like I said earlier, when demoing the Noctua form, as much as possible, we're trying to make use of the existing work that we've already done. But we didn't have everything. And so where we needed to, we filled in the missing gaps and some basic Go annotation. And then lastly, with all that information, linked up our activities in a causal chain to create the GO-CAM. So I'm going to walk you through just some of the individual components of the main model that we made, just to illustrate some use of the causal relations. So like I said, IRE1 is this really interesting molecule, and it has a number of different activities. And so what we did with this is that for each of these activities that IRE1 enables, we linked those up in a causal chain, and we connected them using a positively regulates relationships. And so this would more generally hold for a function that might be enabled by one gene product to causally influence a function enabled by that same gene product. So in this case, we have an unfolded protein binding function that positively regulates the kinase activity function that then in turn positively regulates the endoribonuclease. And then just for the endoribonuclease, in this case, we have inputs and outputs to that. I'll talk a little bit more about that. And then for the kinase activity, we also have an input for that as well. Okay, so this was actually similar to what David showed for a metabolic process. We had the endoribonuclease activity of IRE1, and then next we have the RNA ligase activity of RTCB1. And in this case, the output of the endoribonuclease activity, which would be the spliced XBP1 message, becomes the input for the next downstream activity, which is the ligase. And so in this case, we use the relation directly provides input for. So I'll make just quickly comment on use of IDs in models. So throughout our model, we have simply used the worm-based gene ID for IRE1, even though in reality, what's happening here is that sometimes the inputs might be proteins or unspliced or spliced messages. We're using the gene IDs to basically indicate any gene product of that particular locus, and that's fine to do. So we also have some steps in this process that are gene expression steps. And so what we've done here, after a lot of discussion with the GO-CAM working group, is that we've hooked these different activities up to essentially their targets by using a regulates relation, right? And so it may be, and we certainly know, like for example, in the case of transcription, that there are a lot of other activities, right, that would have to happen in between the transcription factor activity and the activities of its targets. But we don't actually expect that for every model that curators make that has transcription in it, say, that you'll actually fully model the process of transcription. What's key and what's specific about the IRE1 model that we've made is we want to indicate the targets, some of the targets of XBP1. And we believe that this transcriptional step is really a point of regulation or control of the activities. And so in these cases, we've used a positively regulates. And we've done a similar thing between the ligase that is specific for this mRNA, the XBP1 mRNA, and the activity of the protein product that it encodes. So lastly, this is sort of putting it all together, and this is what my model looks like. Basically, starting from the unfolded protein binding of IRE1, it goes through the kinase activity, the endoribonuclease activity, provides input for the ligase that then goes to the XBP1 transcription factor and some of the targets, in this case, protein folding chaperones. And each of these, I've put it occurs in for where the activity occurs. I'll note here that there are molecules like IRE1 that have one domain in the endoplasmic reticulum lumen. They have transmembrane domains, and then they have domains in the cytosol. And so for the purposes of GO-CAM, it is fine to just say for each of these activities that it occurs in the integral component of endoplasmic reticulum membrane, which is the annotation, the normal CC annotation that I would have made for this gene product. And I've got evidence on each of the statements that I've made. And also for some of these, I have added, whoops, I'll show you in the model later, but I have added supporting evidence statements as comments. And that's something that in the future, we'd love to be able to create tools that make that easier to do for curators as well. It's really nice to be able to have those comments there if you ever want to go back to the specific paper to look at things again, or I think just as, for something we can provide for our users as well to see where we actually got the evidence from. There are a couple of things that I honestly didn't capture in this model. So there's a lot more mechanistic detail of how the IRE1 protein kinase activation works. For example, there's cluster formation and higher order oligomerization, and I have not put any of that mechanistic detail in this model at this point. I also wanted to mention that, and we haven't talked so much about this, but we have had questions in the past about, when do I put in, cell type information? When do I provide that contextual information? And it's really, I think, when you feel it's, it's critical to model that particular area of biology. There's something specific about that. So I didn't put cell type information on this model because the IRE1 mediated unfolded protein response, is believed to function in many, if not all cell types. In some of the papers we looked at, they might have looked at, the expression data, say in intestinal cells, but that's just because in the worm, they're big and they're easy to image. It's not really a key aspect of the biology here. So we did not add that kind of cell type information as contextual information. So as we were just discussing with David and Ruth, I think that we found that going through this process really has wider benefits to go. So C. elegans, it isn't the richest source of molecular function information. We have a lot more phenotypic and localization information. So when we were making our models and we really needed to create our function annotations based on sequence similarity, say, when we went looking, we had the same experience. We found that there were really some key mechanistic papers that informed how this pathway works that had not yet been curated for GO. So in the course of this, we have also started on some parallel models for mammals using these papers, so that I think we get the dual benefit of we can annotate what, like I said, are some really key mechanistic papers, get parallel models for other organisms, and then be able also to create our C. elegans model using that sequence similarity. So a couple thoughts on maybe some future work that we might want to do. So I said that, generally the unfolded protein response is a stress response. It responds to acute stress of unfolded proteins, but that's not its only role. There are also times during normal larval development in C. elegans when the skin cells of the worm are making and secreting large amounts of collagen for the extracellular cuticle. If we were to model cuticle formation or development, we might want to include this pathway as well, because that's a case where it is actually used during a specific time and place during development has a specific objective. There's also a lot of regulation of this pathway, as you might expect. There's definitely negative feedback. Once the stress is alleviated and the cells have gone back to proteostasis, we have some of that sort of off to the side of the current model that we had, but we would like to start adding that in to show specific points of regulation of this pathway. And then, of course, there are other unfolded response pathways. As I said in the beginning, there's the PERK-mediated pathway, the ATF6. We have some models for that, as well as our mitochondrial unfolded protein response. So I think, as David said, and Ruth, as you were saying too, once you sort of get into a particular area of biology and you really start to develop some of the expertise here, it becomes much easier to leverage that to make, different or, related models to that. And if that's something that we could leverage more and go and make use of this, I think it would be of benefit to everyone. And so lastly, for the people who've contributed to this work, again, especially want to thank Marie Claire. She did a lot of the initial work on this model, the GO-CAM modeling working group, where we discuss a lot of these things, and of course, Paul Sternberg for his support as well. Okay, so I would be happy to answer any questions.
This is Jennifer from RGD.
Mm-hmm.
I have a question, and it kind of relates to a question that I had for David, and I didn't want to ask it because I figured it probably just showed my ignorance. But I'll ask it anyways because it came up again to me. So you talked about using the gene as basically to represent whatever gene products were actually the things that were involved in the model.
Mm-hmm.
And he talked about one of the processes using oxygen and another using NADPH or NADP. I don't remember which it was. So both of those things are things that would be represented just in the annotations themselves, the Go annotations that feed into the model as annotation extensions, rather than actually being something that's represented in the model itself. Am I understanding that correctly?
So in the case of the metabolic stuff, Jen, at the end of the day, under the hood, all of those molecules are going to be represented because there's a separate project that Harold Drabkin is working on, where he is associating all of the enzymatic activities in Go to RIA, which then associates them with KEBI IDs. And so the metabolites will eventually be you'll be able to drill down to get the metabolites here. But it's actually a fascinating question, because one of the early models that I made, I actually had the hydrogen peroxide from the oxidase activity going out and feeding into the glutathione system in the cytosol and to catalase in the peroxisome. And then I took that out because I thought, no, you know what? That's not part of this pathway. But in cases where I think the molecules are critical, you can always put them in as an annotation extension, keeping in mind that the general reactions under the hood, they're all going to be cross-referenced to RIA IDs. Does that answer your question, at least for metabolic pathways?
Yes.
Okay.
Because it just seems like it's important information. And if I look at it this way, I don't see it. So hopefully at some point there'll be some kind of a visualization where you can see those kinds of details. You can see that has input XBP1 and has output XBP1 is, not necessarily, that's not necessarily the exact same thing. It could be two different products.
Right. So in the case of metabolites, right, Harold is going to jump in here. In the case of metabolites for enzymatic reactions, we're going to mine that from Maria. In the case of the XBP1 here, what mouse curators have the ability to use the unmodified Pro ID, and then the modified form Pro ID for the inputs and outputs, and they would have to curate that.
Or even cleavage products for that matter.
Right. Yeah, sorry. I was thinking it was a kinase, but it's not.
Except for cleavage products of RNAs, because we don't use those IDs yet. But
yeah, so Jennifer, I think a lot
that gets cleaved, we can't really functionally add IDs to that at the moment. So we'd have to default to the gene.
Yeah, so Jennifer, I think
for proteins, Harold? For RNAs, yeah,
no,
for
no,
proteins.
for RNAs, like the endonuclease or something, and it gets cleaved, we can't really tell you what, we can't give an ID to each of those products yet.
It's something that I guess is sort of early beta stage, is that both for MGI's purposes and for reactomes purposes, there's a lot of annotation that goes at modified forms of proteins. The Pro ontology captures that material, and in fact, identifiers from Pro can be used. When Kimberly was showing early this morning, getting identifiers from friendly ontologies to import into a GO-CAM model, Pro is sitting somewhere in that menu. So that is in the process of allowing statements to be made about this particular modified form of this protein, for example, and assigning it a different set of attributes than the canonical form of the protein or a differently modified form. For RNAs, I guess, in principle, I don't have to program anything, so it seems sort of like a similar problem. Ought to have a similar fix, but that's way off in the future someplace.
Yeah, so Jennifer, I think in part it boils down to, what different annotation groups have available to them as specific IDs to use. Certainly, right, at Wormbase, we don't have separate IDs for, this particular unspliced and spliced message. But there may be, maybe we could explore other ways of expressing things like that without maybe necessarily having to have IDs for all of those things at each of our respective mods or curation groups.
Yeah. Yeah, I mean, we annotate to genes, so we have protein IDs, and we actually have IDs for RNAs as well, but we don't generally we don't at all use them for annotation.
Mm-hmm.
It would be a possibility for us to do that, but we never have. So
right.
I'm not saying, gosh, you should do it like we do, because actually you do it like we do.
Yeah.
So.
Yep.
But thank you.
Yeah, this is another case where, right, balancing, right, the specificity of what we can capture versus, right, how quickly we're able to annotate things as well.
Right, and that's always the balance.
Yep. What, are there any other questions?
Yeah, it's me again.
Hey, Ruth.
So I will lower my hand. So I find what I find challenging is knowing how this will create normal Go. I call them normal Go annotations.
Mm-hmm. Mm-hmm.
And so I find it easy. I'm just looking at the kind of far right hand end of your lovely graph, and it's so and it just looks so lovely. And I'm also just wanted to say I really like the fact that you've done similar to what David did, where you've put all the proteins here associated with a single overarching process. I think that looks really good. David did it in a slightly different way, and then he had it just all in one bunch and then had all the arrows, but that's great. But I am just struggling with how, so would you say that the DNA binding transcription factor, will it, other than being involved in the process of the unfolded response, will it have any statement about the fact that it regulates protein. I mean, I don't know that it should, but you know that it says that it's regulating protein folding chaperone activity. Will that be exported in any way to the normal Go annotations?
Yeah, so if the way it would work, right, for the GPAD output, right, is that, you know, if the evidence for the DNA binding transcription factor activity, Neobex BP1, you know, is the same as positively regulates, then the target essentially would be output as an extension in the GPAD, right? So that would just, it would be the same rule that we use now for making the conventional annotation.
Yeah.
Yeah.
But you wouldn't have the fact that it regulated protein folding.
That's what you would actually have.
Yeah.
Oh, okay.
Yep.
And then for the endoribonuclease activity.
Yep.
Because you've got a different relationship there. So here you've got the directly provides input for. So I have no idea how that goes. Whether that gets changed into, you know, anything in the GPAD format.
It would again be an annotation extension on the function.
Yeah.
Term.
Okay. Yeah.
But one of the things we need to decide is how much of that do we want to represent, right? If you look at the conventional GPAD annotations that are coming out of some of the bigger models now, they've got massive amounts of extensions on them. And I really think we need to call that and say, if you want all this information, you really need to get it somehow out of the model rather than trying to put it all in a conventional GPAD line.
Yeah, I suppose what I'm partly trying to say is, for example, you've got an endoribonuclease activity. So, well, I guess it's not so much for that one. It's just some of the ones. Okay, the one before, the unfolded protein binding, and then you say positively regulates the serine threonine kinase. Should it, if it's actually binding to that protein, shouldn't it be shouldn't there be an annotation that it inhibits, if that's what it is, or it activates, or it regulates somehow the activity of a serine threonine kinase?
Yeah, so that's a very good question. What I haven't done here is turn on the reasoner to show you possible inferred annotations, but also we've been discussing a lot in the modeling group of things like activator and inhibitor molecular functions, right? And when we would want to have those inferred and when we may not. And you may recall discussion we had this summer about specifically with respect to that and when these different functions are enabled by the same gene product. I think there's a little bit more discussion that we'll probably have about that. But in this case, in this particular case, because it's the same molecule, yeah, we would not get that sort of activator activity.
But I guess I should have just looked more closely. So I guess it would work on the second one is what maybe I'm trying. I don't know where I'm going. I just hope that one of those things is supposed to activate some kind of enzyme activity, but I'm not sure that I'm achieving that. Anyway, that was my thought.
This one is a little bit different, right? Because it's all by the same gene product, but when they're two different gene products, that's what we've been discussing a lot. And I think, yeah, we'll want to discuss that further and make sure that everybody's happy with what they would get out.
Okay, lovely. Anyway, thank you.
So, can I just ask? So this pathway, I'm not that familiar with it because it's slightly different in fission yeast. I know that, but I know the definition of this pathway because I've just looked. It ends with the regulation of a downstream cellular process, e.g. transcription. So the way I've annotated this would annotate is that the transcription factor would be the last thing in that pathway. That's where it would end. So then I see that the next thing, the protein folding chaperone, is also annotated to the pathway. But is that because it's involved in the pathway upstream as well, or is it, because this is presumably a gene product that's transcribed by this transcription factor, is that right?
That's right.
But that's not part of IRE mediated unfolded protein response, is it? Because there is this, isn't this bit just the signaling pathway from IRE1 to the transcription factor?
When we made this model, we went one step beyond the transcription factor to show some of the targets that it transcribes that are actually, then involved in going to the endoplasmic reticulum and folding some of the unfolded proteins.
But isn't that then the other term? It's a weird thing. I think that, I've ever got this the right way round, that this part is the signaling is called, it is weirdly named. This part, it might not even be this, but this part here, the transcribed things, I would annotate those, but I wouldn't have annotated them as part of the IRE mediated unfolded protein response, but only because that's not what the definition says, but I think that this is considered to be then unfolded, ER unfold. This is another, I think it's, so which, yeah. But this is why it's good if we're all on the same page with the starts and ends of the process when we do the models.
Yeah, and we may want
to. It's a very old discussion. And what we're seeing maybe is that there's nothing like drawing it out as a diagram to see that there are two different views of the boundary.
Right. Yeah, we may want to revisit, I think, the boundary of that term, of how it's described in the ontology.
So what's the chaperone again that it transcribes?
They're essentially BIP orthologs, heat shock protein.
Which is the thing, yeah.
Sorry?
That's involved in it anyway, BIP. So it's involved in it. It's involved in the process higher up.
Well, that's an interesting point. That's actually one of the negative regulations that we have sort of off to the side of this model. But it does both things. It's involved in negative regulation. It's also involved in, the actual folding of the misfolded proteins to respond to the stress.
But Kimberly, as Peter just pointed out, pathway boundaries in these diagrams it's a great example of how things can differ, right? So in the nucleotide catabolism one, obviously the human pathway is going to end with urate. It doesn't have the enzymes to process it, right? And so if I were defining that pathway in humans, it would end with urate, but in plants and in other animals, it gets catabolized further. So pathway boundaries are something that are very difficult, and it's going to be interesting to try to always nail them down in the ontology.
Mm-hmm. Okay. So the next presentation and model that we have up, Pascal is going to talk about transcription regulation.
Hi, I'm going to share my screen. So the idea here is mostly to, can you see?
Yep.
Okay, thanks. Because we've been, I think, trying to have a template for transcription for a long time, and there's been like many discussions, and we go back and forth sometimes. And so this is the current way, hopefully stable, that we want to represent like how transcription factors work. And so I have like a bunch of introduction slides that I gave many times at Go meetings and like transcription workshop and so on. So we talked about this a lot. But just to say that, there's the general transcription factors that bind to the core promoter. And then there's what we call DNA binding transcription factors that bind to specific region of the gene's promoter. And then there's cofactors like the mediator, that, for instance, can bridge transcription factor with the general transcription machinery. Okay, and so this is the high level view of the activities. So we have the DNA binding transcription factors and the co-TFs that are involved in regulation of transcription, and the GTFs and RNA-PAL2 are involved in transcription. Okay, so I hope I'm not going too fast, but I think this has been done often enough. And so in the past couple of years, also with the help of Colin Logie and Ruth and Val and other people, we have, well, Paul, we have refactored the transcription branch. And so how it is now is that the GTF, and then this has 3 children of GTF for RNA polymerase 1, 2, and 3, is a direct child of molecular function, and it's part of gene expression, so part of transcription. Whereas DBTF and CoTF are transcription regulator activities, and they regulate transcription. Okay, so they're transcription regulator activities, but only the co-regulator we put as a molecular function regulator. Okay, the DBTF is a process regulator. And so there's also the DNA binding branch. So this is kind of just the very top level. So you can bind, you know, the most top level term is transcriptions regulatory region sequence specific binding. And so this is really what defines a transcription factor, is it binds a sequence specific way, a unique motif to regulate like a specific set of genes. So they're more specific than the general transcription factors, for example. And so you can bind RNA-PAL2 transcription regulatory region. There's also cis regulatory region. There's RNA-PAL3. There's core promoter binding. There's intronic regulatory region binding, and there's PAL1. So this is just the order in which QuickGo outputs this. But and then there's more specific terms like PAL2 cis regulatory region sequence specific binding. And so whenever possible, there is a link between this term and the DBTF term in the ontology. So the, let's say, RNA-PAL2 transcription factor activity function has a link, has part RNA-PAL2 cis regulatory sequence specific binding, okay, which is a child of that term. So just to say, like on a practical note, is you can annotate DNA binding if you have specific evidence you would like to capture, but it's not required, as you know, it's a part and it should be inherited. So I don't want to read the slide, but for reference, you have the definitions of GTF, DBTF, CoTF. And we come to this slide, which I would like to enlarge. Well, or I can go here. And so this is the model. So here I did put the binding annotation. Okay, so here we have a model in which p53 regulates expression of CDKN1A, which is also known as CYP1 or P21. And so P53 binds a specific region in the promoter. And to address David's comment from earlier, here maybe we could have like the SO element it binds. It's a SP1 element, I think, but I couldn't find, like we don't have this in Go, but so this is something else that could be added here. And then this is part of the, so this is what we call a compound function, the DNA binding transcription activator activity enabled by P53. Okay, part of its function is DNA binding. So, and this has the input CDKN1A, which is part of the process, positive regulation of transcription by PAL2. And so this activity regulates, okay, indirectly via the transcription, but it regulates the activity of its like the gene it regulates, right? So here we say that CDKN1A is a serine threonine kinase inhibitor. So it inhibits, oh yeah, here this should have been 2 boxes actually. It inhibits, so just to take a little break, this part here, these 3 boxes and the downstream is sort of the core template for annotating a transcription factor. And so the rest is just, you know, what does the downstream gene do? And so in this case, this CDKN1A negatively regulates the CDK2 kinase, which is part of G2S transition. So this can stop, it can cause a cell cycle arrest if it's activated by DNA damage. And then I think this should have been a separate activity, like it should have been a separate instance of the DNA binding transcription factor activity too. So I'll just, right, Kimberly, I think I need to disconnect this one.
You don't have to right now, but
okay, I don't know, it's driving me nuts. But I think, you know, I think it binds a different promoter and it regulates a different gene. But so, you know, just to say that the effects of this protein is on multiple genes, obviously. And so this is, so what it does is it inhibits PCNA, and PCNA is necessary for cell cycle DNA replication. And so that means that if you activate the inhibitor, cell cycle DNA replication cannot take place. And so generally speaking, you know, the CDKN1A is part of the signal transduction that is involved in the DNA damage checkpoint. So this is what this model represents. I think we probably want to have a template that covers just, you know, these 4 boxes, and this would just be molecular function and enabled by, you know, we don't know what it's enabled by, so you would fill in the molecular function of the target gene here. So I think this is all I had. Oh yeah, I was, you know, I wanted to maybe draw like the co-regulator, but the co-regulator will, in most cases, act on the DNA binding transcription factor or will act on the chromatin structure to also regulate transcription. So are there questions or comments about this? Great, so we finally resolved transcription.
Just one question, because I've never used a template, Pascal.
Oh.
So when you have a template in general, can you just copy that somehow and then start with that?
I think the template is still a theoretical construct, but the idea would be, yes, you would have all the terms and everything kind of empty, and then you would know that, you know, you would copy it, you would clone it. So this famous cloning functionality.
So this full functionality of template or the nicer functionality would come if you can then copy this and then fill it in where what we
I mean, exactly. I think we do have models that are called templates. I don't know that there's a specific status for templates. You know, I think we would want like the templates to be non-editable or only editable by Kimberly.
Once you import them, or once you import them then into your model, then you can maybe
of course, yeah. So you
but the template itself, exactly,
the
template itself should be controlled, exactly.
Yeah, right.
Yeah, but just the important thing here is that you can see this looks just like the way we would create any activity, right? So you could do this in the you know, in Noctua form. You know, you can say basically TP53, and then you can go either select an existing annotation to some transcription factor activity, an existing annotation to chromatin, and then add the has input extension to say which gene it's operating on. So and then obviously put the part of a process. So all of this can be done, doesn't have to be done in the graph, right? So all of this again is something that the form is really well set up to do. And then at the end, you can connect up the activities in the graph. And what this is basically saying is that the transcription factor activity is upstream of the activity of its target, right? And so this again, I think is pretty intuitive, and that's the only thing you'll be using the graph editor for, is just connecting those. So so she's sort of walking you through the graph representation of the final model, and that may not be the easiest way for you to conceptualize it, and certainly not the way you'd curate it.
Okay, any other questions?
Okay, great, thank you.
All right, thanks, Pascal.
So Val, your hand is up.
I think that's from before.
Okay. I'm just trying to keep track.
Sorry, I keep forgetting that I only discovered it today, the hand putting up.
All right. Okay, so we have finished up more or less on time for today. There's about 15 minutes left. I think maybe in the remaining 15 minutes, I just want to, first of all, thank everybody for coming today and asking such good questions and giving us feedback. It really helps to have the input. But I think by way of closing, and then we can stick around for a few minutes, the remaining 15 minutes or so, if anybody wants to just try Noctua. And then if you have any questions or need help, we can help you out. So tomorrow we'll start again at 10 Eastern. And so in the agenda, I've put at the very bottom, if anyone has questions that you either didn't get to ask today or think about between now and tomorrow when we start up again, feel free to put them here at the bottom of the agenda, and we can go ahead and talk about those tomorrow. So the idea is that tomorrow we'll have a little bit of just check-in discussion in the beginning, and people can actually do some hands-on modeling. And so the working group, we will be available to address any questions. We are going to try to set it up, if need be, kind of similar to the way we do the Go meetings, that if people want to go into a specific, say, breakout room on the Zoom, so they can maybe work one-on-one or small groups in particular areas, we're going to try to do that. You can also certainly put any questions you might have in the chat. We're also, most of us are available on Skype. So however it works, if people want more one-on-one attention, we will try to accommodate that. We'd also really love it if people could present their models as we go along. Just so, we can get an idea of, what people, find easy to do, what they find more challenging to do. It would, I think, be a benefit to everyone, for all of us, to discuss these things. So don't be shy. We realize that a lot of the people here at the Jamboree and the workshop are still quite new to this process. And so, like we said in the beginning, one of the goals is to really try to get people more confident about the process, about using the tools, and get you on your way towards making a process-centric model. But we expected and anticipated that a lot of people would be at the beginning of this process, and so we want to help you learn how to do this. So Petra and Bob very kindly have already offered tomorrow to present one of the models that they've been working on for DIGD, and is chemotaxis to cyclic AMP, and they just put together a few slides, 4 slides that we can refer to. For presentations and discussing your models, you don't have to present slides. It's perfectly fine to just, show your model and we can discuss it from there. But we would really love it if people could take some turns in presenting what they're doing. And so with that, again, I think I would just emphasize the overall workflow that David and Paul and I have talked about, which is, if you think about the process you might like to model, learn about that process from review or a very recent publication. For your organism, figure out, what are the genes or gene products that you would annotate to that process. Look at the Go terms that you might include in that. See what you've got for existing annotations as much as possible. Use what you already have. If you want, you can fill in the missing gaps. Like we had said earlier in the emails for this workshop, we don't necessarily want people to spend a lot of time going out looking for evidence. That's something as Go curators we get a lot of practice doing. We're much more interested in have people learning about the causal relations between activities and to be more confident on choosing the correct ones and hooking those up. So keep this workflow in mind for this week. And like I said, don't hesitate at all to ask questions. Is there anything else that anybody wants to add for today?
Thank you. It was really all very good.
Yeah, and I just wanted to emphasize, please everybody feel free to ask questions. That there's this is all, I know this is all kind of new, and it's going to be, it may be difficult at first to think about how are the annotations connected in the model, and so please don't feel that there's I just want to like there's no such thing as a dumb question. Like it's this is a difficult thing to wrap your head around at first. And so, please feel free to ask questions, because I guarantee you someone else will have the same question. So I just really want to emphasize that we want this to be really interactive, and and please don't hesitate to ask any question, and don't hesitate to ask it more than once. If the answer later on becomes not as clear as it was or as it seemed the first time. So I just really want to reiterate that this is really our chance to have a very interactive session here.
Okay, so I'll stick around for another 10-15 minutes. Just if anybody has questions or just wants a hand getting started with Noctua. Otherwise, we'll see everybody tomorrow, same time.
Thanks, Kimberly.
Thank you. Thank you.
Thanks.
Bye.
Bye, everybody.
Bye.
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 Goodbye.
Kimberly?
Yep. Hi, Colin.
I put my question in the agenda like you suggested, but
Oh,
basically, I very much liked what you did, and I was just following you doing cloning, basically recreating the thing that Pascal showed, and I noticed it's nice in the form. You can really import things. So I got all the suggestions. I just clicked everything. I took it. And then I realized that some of these molecular function annotations actually also contain the target gene, but I get them for the molecular function, but I don't get them to automatically populate the arrow between P53, the transcription factor, and its target genes. It would be lovely to do. And when I actually discussed this briefly during the break with Ruth, and Ruth says, also said, yes, some of these things are there. So some of the relationships that have been curated say in this paper that transcription factor does that target gene. Right. So it might be nice if this can be that you know, these relationships which are already explicit, in fact, in Go, could be imported into the Noctua models. I guess that's the upshot. But meanwhile, it would be nice to know how to do it, because certainly what I could do in the form, and I couldn't really do in the graph representation. So it was much more difficult for me to put a PMID there, basically. I did it and it didn't accept it. And so then, for my own sake, I put it into the comment, and then the number of things that were not annotated went from 3 to 4.
Good job, Colin. You got it. Yeah.
But I guess we'll be busy the whole week trying to build things here, and it's really nice. So
yeah. So Colin, you can actually in the form, when you annotate the function at the end of that line, there are those 3 dots.
Yes.
If you click on that where it says add an extension, you can add an input. And that's where the input is the way we phrase what's the target of the activity.
I see. Yep.
And so if you add that has input line, then you can actually edit that line in the form. The bummer is, as you say, you're right. We should be able to import those from the annotations, but we can't do that yet. We can only import the sort of simple part of the annotation, not the extension. We'll get there.
Yeah. No, obviously, and this is nice. Yeah. I mean, I've been talking with people from Ensemble yesterday or 2 days ago, Friday, about this. Yeah. And so, what I'm going to try to do with Pascal and Ruth this week, ultimately, we want to reverse the flow, and we want to be able to take the GFF files, which, annotate the whole genome and epigenome, and sort of say these transcription factors binding all of there. And we would like to sort of take that information and put it into the models automatically,
Mm-hmm. Yeah, so that's one of those things where we can work with you individually with one of our developers to do the automatic import, and then you can just edit the model once it's imported. Yeah.
Yes, because then we have a black box in the middle, which is how to assign all these things to the right genes. But we've got the framework, and also in SO, so we've got the logical framework. But the ambition this week is not yet to do that. It's to lay the ground so that we have the right vocabulary, that I understand that we can use the right way of doing it in GO-CAM. But ultimately, I think the way the information is going to flow, it's going to go the other way around, actually. So we're going to have these big GFF files which contain a lot of information, and we'll try to build pipelines to just allow all the genes to have their transcription factors.
Great, that's exciting.
Yeah. I find it too. I really enjoyed today's session, and I think this boundary of the processes, this will disappear at some point. This is really purely words. Obviously, information keeps flowing. There's no stop to it. Eh?
That's right.
But thanks a lot. I'm going to log out. So
great. Thanks, Colin.
Great questions.
Yeah. Yeah. Okay.
All right. Great job, Kimberly.
Last man standing.
Yeah, I just can't bring myself to leave the party.
Yeah, it's interesting. I was getting chats, and chats I was getting was like, I think people felt even today was more detailed and advanced than they thought. So I think, this week, let's just keep reiterating how to keep it simple.
Yeah, exactly. And I think that once they start walking through some examples, it'll become clear. Mm-hmm. It's not till you really use it that you sort of get it. But I think, if you want to just, start tomorrow by just, again, just mechanically walking them through the process, like, maybe even show them like, here's my hand drawing of this pathway based on these things. And then here's what I did next, and just open up Noctua. Okay. And, just go, here are the steps I went through, and just kind of, at least create 2 activities. Okay. And then go back to the editor, 2 activity units, and then go back to the editor and connect them, and just say, that's it. right?
Yeah.
So just to say, you know, I know we gave you a lot of details, but at the end of the day, here's mechanically what you're going to do.
Yeah. Yeah. Okay.
And so I think that would be a really useful way to start out the day tomorrow.
Okay.
Is just to give them, you know, just here's 2 activities, and I'm going to do it all from scratch right now, right here for you.
Yeah.
Okay. Because I think they'll see, as long as you can use the existing annotations, it's really fast. And you might want to pick one where you had to add 1 annotation.
Okay.
You know, and just say, all right, here's the annotation I added.
Mm-hmm.
You know, and here's what I did to add it. You could even say, you know, I went and I searched for a paper, and this is the PubMed paper I found, and you know, so just to really walk them through mechanically, because I think that's kind of the end of the day what we want to make sure that we leave them with before they start to do it, which is, what are the mechanical steps I go through?
Right. Okay.
Yeah. Cool.
All right. Sounds good. Okay.
Great. Thank you.
Thank you, Paul. Yeah. See you bright and early
Thanks again.
tomorrow.
All right.
All right. Bye-bye.